Everyone here all set to go?
What was that, sorry?
Oh, I was just saying, is everything all set to go? All the slides uploaded?
Yeah. Well, not all of them because we don't have everything in Indico, but we will manage.
Oh, okay.
Yeah.
And what is in Indico, you could set to download. So when you go into the manage presentations, there'll be a little download icon. I would recommend having them all set.
Oh, okay. Yeah. Okay.
And what that will do is it'll create a little download icon to the bottom left.
Mm-hmm. Okay. But yeah, I mean, I assume that because there are, okay, which ones? There are two activities for which we don't have presentation materials, but I expect the presenters to provide them.
Oh, so they're not going to be using it, or they're not. How are they going to do the slides?
Either. I don't know.
If they have them in PDF, they could upload them, or you could upload them.
Yeah. That's the idea.
So, just to make sure that thing works.
Mm-hmm.
Yeah. So, and actually, I've done this before, where someone sent me a slide saying I need to update my slides during someone else's talk. So what I did was I kind of stole presenter from them, uploaded the slides, and then switched it back to them while they're on one slide. So
yeah.
Also, a little hint. Actually, let me go to the shared notes to see if you have it. Let me go. So, are you familiar? Are you logged into Matrix through the website at all?
No.
This is the what's the actual title of this track today? Today's track.
Toolchains and Kernel.
So there it is. Yep. So in the shared notes, I just pasted Matrix.
Yes. I am connected there. Yeah.
So if you want to use shared notes, which I highly recommend taking your notes here, since you can't do chat and notes on this window, what I've been recommending people to do is in another browser window, go to that link because it's the same as the chat, have that up and running, keep here the notes here, so you can type in the notes, but if you want to look at the chat, you can just switch windows, look at the chat, and switch back.
Yeah, that's a good idea. I'm actually doing it.
Okay.
Because in the tools track, we did not use the shared notes that much, so that was not that necessary.
Well, in the microconference, I'll be asking everyone to.
I know. Not my first rodeo. I know you will come after me for weeks and weeks and weeks and weeks and more weeks. You will not forget ever about it. Yeah.
Well, the great thing about this is that actually it's great for material for next year's. When you do next year's, you can reference it. So
there is no way to make the submission of the microconference without access to the shared notes from the last one.
Basically,
I know.
So that's okay. So it looks all set. I'm going to go check out the other ones. I'll probably pop you into. There's a few topics I want to see on this track. So I'll probably pop you in and out.
Okay, great. Thank you.
Yeah.
Ciao, Steve. I don't know if we have any of the presenters already. No, like testing audio, video. Okay, so Rust is Miguel. Check tool is Josh. Standard committee is Paul. control dependencies. Voltis Maxim. A compiler features for securities, keys, and king.
Hey, Jose.
Hey, Nick, how you doing?
Hey, good morning. I'm about to put a pot of coffee on.
Yeah. Yeah. All right. So basically, current situation, I uploaded the presentations for all of them that we had in Indico, which is 4 out of 5 out of 6. We are missing presentation materials for the Bolt. So I don't know if Maxime, as soon as he joins, we can ask for the presentation. And also the other one which is missing is for the Rust talk. So again, I don't know if Miguel is already here. No, he's not. Okay, so we are supposed to be taking notes. Now, how are we gonna handle the notes?
I can work on just typing them up in the shared notes. And I just got to make sure to copy and paste it into like an email between us for afterwards.
Yeah.
Yeah, I'm going to put that pot of coffee on.
So I will be handling the.
Cool, that's good.
Yeah.
You want to give the intro too?
Yeah. I mean, yeah. Why not? I mean, unless you want to do it yourself.
Nope.
Keep it short because we don't have time. So I wonder if Miguel is around because we don't have the presentation material.
Okay, let me see if I can reach him on like IRC or something.
Yeah, he may be around, yeah. You know, something that is missing in Big Blue Button is a clock, you know? I noticed last year already.
A big timer that's a countdown clock.
Yeah, or a clock, just the time, you know,
Sure.
in your time zone, yeah?
I mean, that's good feedback for Guy at the end because I'm pretty sure that a lot of work went into designing this whole interface. Like, I don't know that the matrix integration is part of Big Blue Button generally.
I'm not sure.
I think there is a fair bit of web development that goes on to customize the embedding of Big Blue Button for Plumbers. Could be wrong though.
Oh, it's very impressive. I was very impressed last year already.
Yeah, especially how quickly they got everything up and running.
Yeah, and that it actually works, you know, like with hundreds of people connected and, you know, videos, audios.
I mean, what's nice is even Jonathan Corbett kind of administers it, from my understanding, and he's like happy to let people use it for kind of their other conferences and stuff, tangentially kind of thing. Like we were pretty close to reaching out and saying like, hey, we might need to use Big Blue Button as a backup for a conference that we had virtually. It looks like Miguel is online now or connecting.
Oh, cool.
Probably doing the mic test right now. And I think Max is here as well. Max, if you have your slides for Bolt, is that something that you can send us real quick? Folks might not actually be at their computers, I guess.
And Miguel is here. Miguel, hi.
Yeah.
Okay. I think it would be good to test your audio, your video, and also we are missing your presentation materials.
Yeah.
You got.
Let me upload it to Indico. 1 second.
Okay, yeah, thanks. Okay, 7 minutes to start. So Maxim, if you can hear me, it will be useful if you could upload the presentation materials for the Bold Talk to Indico as well. So we can upload it to the BBB.
Okay, that sounds good.
Thanks. So Miguel, are you having problems with Indico?
No, sorry, 1 second. I'm
Okay.
switching between two computers. 1 second.
Yeah.
I've definitely fairly recently had issues with like webcam and audio and been dialed into a meeting twice. Like one for video and one for audio.
Okay, I see the presentation in Indico. Let me download it and then upload it. The Rust toolchain. Okay, now let me upload it here. The Rust toolchain. Upload. Okay. Good. 3 minutes to start. Okay, let's see. Wow. Oh, yo. 47 slides.
You better go quick, Miguel.
Nah.
A lot of them are backup slides. Don't worry about it.
Hi.
Yeah, a lot of it is basically rediscussion of what we already discussed in several places. But
Okay. Okay, 2 minutes to start. Okay, 6 o'clock on my watch. So, Nick, should we start? Cool. So, welcome everybody to the Toolchains and Kernel Micro Conference in LPC 2021. So, let me go very quickly through the default slides that you have seen like 20 times already. Okay, sponsors: Facebook, IBM, thank you very much. ARM, Microsoft, nice to see you here. Amazon, Netflix, Red Hat, Collabora for the nice USB gift sponsor, speaker gifts. VMware for the t-shirts, thank you very much. The Linux Foundation for the conference services, which work very well, so thank you too. Anti-harassment policy, be nice with other people, then we all will be happy. Housekeeping, this is the last day of the conference, so, well, I mean, everyone knows this already as well. The planning committee, thank you very much to you all. We know the pain, we appreciate your pain. So I wanted to say something very fast. This is a LPC micro conference, meaning that we are not gonna have talks here, or that's the idea. In theory, you are supposed to be using like 1, maybe 2, maybe 3 slides per activity. I have seen the presentations, that's not gonna happen like that, but let's try to have as much discussion as possible. So you have a problem, you need the kernel hackers to fix that problem, and then you want to discuss about it. So, because that's what it's supposed to be. So let's go, let's start with the first one, which is Rust in the kernel. So this is Miguel Ojeda, and thank you very much.
Okay, can you see me? Yeah, I think so, right?
Yep, sounds good.
So, well, this presentation, as you were seeing, is basically all of it is backup slides, and I wanted to have as much discussion as possible because in the other talks we had, basically we took most of the time explaining things. So for this one, we wanted to have as much discussion as possible and leave as much time as possible. So the slides are just basically the questions about the toolchain that we have had so far, and the ones that I put in the abstract, all the questions that we have. I have answered for all of those in the backup slides, and we can go through them. But again, if somebody wants to discuss something else, please let us know. These are the questions, and I will go through this. But again, if somebody wants to discuss anything else that appears in these slides, basically that I am going through it. Some of these we discuss at the beginning of LPC, some of these we discuss in the Clan Big Linux meetup last week as well, also in Cangrejos. So there is a lot of things we can discuss about the toolchain. And these are basically all the topics and all the things that we have. So I will start answering basically those basic questions, and then ask any question or anything you have about that. So the first question is which particular Rust toolchain is needed right now, and To answer this, we need a bit of background in the sense that Rust, as you know, is a language that exists in C++ that has some features, but there are some features that are unstable, what they call unstable. So instead of releasing, for example, an extension to the language, like in C, like GCC does, for example, they extend the language and then they, I hope, support the extensions that they release forever, right? In the Rust language, they prefer to have like a transition period or a beta period or a testing period of a feature. So they release a feature as unstable, right? And this feature can only be accessed in the nightly compiler. So you cannot use that feature in the stable compiler, in principle. So in the kernel, we need some unstable features because there is some, sorry, okay, that's sorry. So we have in the kernel we have we need some features from the Rust compiler, both in the language, in the library, even in some tools. In the tooling, we need a few. Someone is typing. Okay, we need some features. So, but at the same time, we need to use a stable compiler. We want to use a stable compiler. So there is this tension between the features, the unstable features, and the compilers, and what should we use, at least for the beginning. So for the moment, what we have done, and this is basically the answer to the question, is what we have done is use a stable feature with escape hatch that allows you to use unstable features, and therefore the toolchain that we use right now is the stable one. So you only need to have the stable toolchain installed. But we use it as if it was a nightly, so to speak, because we use unstable features. We have a question already. Lucas asks, where can we read about compilation process in Rust? How does this process work compared to C pre-processing, compilation, and linking? Okay, so I have some slide about that. Let me see. Can arrive there. Well, we can use this because that allows us to also explain the. So in Rust, the compilation process basically, first of all, you have a translation unit, and a translation unit, as you know, in C is your C file basically, plus all the headers that you are including through the preprocessor, etc., etc., etc. In Rust, the equivalent is the translation unit. In Rust, it's a crate. So a crate which can contain many files is a compilation unit. So far in the kernel we have, and let me go first to this slide to explain that. 1 second, I arrive there. It would be nice to have like an index here to be able to these kind of discussions, to jump to a particular slide. So here you see the crates. So each crate here will be like a compilation unit in the C side, right? So as you can see, we have one which is called kernel, which doesn't mean it's a new kernel. This is just the place where we put all the abstraction for the kernel. So you can read it as the Rust abstraction for the kernel. And this is a single compilation unit, a single translation unit, which of course makes it so that it will grow, and probably we will need to split it, right? But that's basically how it works. And in the kernel, what we do for the compilation, we don't use cargo. And what we do is we compile these crates. Of course, since they are compilation units, we compile them individually. So you compile the kernel crate on one side, you compile the built-in crate on another side, you compile also the core crate, we compile also the alloc crate. Some of these depend on others. Something like I don't know, so like the headers in C, you could say it's not saying, but what I mean is that to compile the alloc crate, you need to have compiled the core crate first. So you need to have it available already compiled. So it's not just some. I mean, there is some things that require some metadata from the other crate, but that metadata is basically what you would have in the header in a C program. So there is some metadata that the one crate needs to be able to compile and link to the other crate, right? Or let's say just compile to the other crate. So you build core, then you build alloc and built-ins, etc., and then finally you build the core. The kernel crate. And after the kernel crate is built, then we go to all the drivers, for example, or all the modules that are written in the kernel, and they link into that. So they need, or they depend on the kernel crate. There are other details like the bindings crate, the bindings crate we can also discuss, and binding. I have a question about that as well. But yeah, basically there is some dependencies that you can see here, more or less simplified. and we have to go step by step. And for the Rust support, we did it like this because initially, long time ago, what people was doing was, the original support was, or how people have done external module for the kernel, even in Rust or in other languages, is to build like a static library or an object file or whatever, completely independent from the kernel, as if it was with anything, all the dependencies there in that file or in that archive, and then just create a KO from that. But of course, in the kernel, we don't want to do that. We want to share everything. We want to share everything I mean, all the abstractions for the kernel C APIs and all the core. So instead of repeating core analog in every single module, we don't want to repeat all that support, which is actually quite, I mean, takes some space. So we don't want to repeat all that. We want to have a single place in the kernel which contains the Rust support, and that is what we call the Rust support option in keyconfig. So if you enable that, you will get core, you will get alloc, you will get kernel crate, the built-in crate, the bindings crate that you see here. This macros crate, ignore it because the macros crate is like a plugin for the compiler, so ignore it for that purpose, ignore it. And then when the Rust support is enabled, then you can enable all the other modules, which is depend on that. So they can find the other crates. For example, if you are compiling a driver, it will need for sure the kernel crate, and the kernel crate on top, it will depend on the others, etc., etc. So that's basically the compilation process that we follow. There is also binding, but I will go back to that. Please keep the question coming because it's basically the most interesting part, I think. So we have another question. How can the Linux kernel community who are interested in Rust help accelerate the GCC implementation to ensure that Rust has the same portability and diversity of toolchain support as the current kernel implementation languages? Encouraging cooperation between Rust, Rust-C, Rust Foundation, and the new toolchain, participating in the new toolchain development, and or providing funding for developers, etc. So this is from David, which is from the GCC steering committee, if I'm correct. We discussed this yesterday a bit. Basically, I think without getting too much detail, we need, from the kernel perspective, at least from the project perspective, we need some features from Rust, from the language, from the compiler, from the tooling, etc. If Rust is going to become a language in the GCC, in the compiler collection, then we will also need support there. And we hope that we can support as much as possible the alternate backends. So for example, I can also explain that because it was also a question here. So let me first perhaps clarify what are how the different frontends that we have right now. Let me go to the slides. Sorry. No, it should be in the end. Or sorry, here. Yes. So there is right now, or at least since the beginning of Rust, they implemented, not in the beginning, but basically in the after 1.0 of the compiler, let's say, they have been using what they call Rust-C code general LVM, which is the backend that so they have a frontend that is everything Rust, etc., and then in the compiler they have the backend, which is LVM. This is the main one, is the one that has been used, is used everywhere basically. But there are two projects, or there are more projects. There is also another project for bootstrapping the Rust compiler from C or C++, if I don't remember correctly. But the other two main projects that they have funded, most of these projects have funded, as you can see here in the slide. There are two different projects. There is Rust GCC, which is a new frontend for the GCC compiler. So this will be like the ADA frontend, GNAT, or I'm not sure how it's pronounced, or the Fortran frontend, etc., the D frontend. So this will be like a Rust frontend, GCC RS. It's coming along very nicely. We have a rough estimate from the developers. I think we have the developer here, if I saw correctly before. Yes, we have Philip here. So Rust GCC is yeah, Philip, go ahead. Please go ahead and answer that if you want.
Oh, I guess, yeah, so I think to get to like a minimum viable sort of working compiler, we're hoping in a region of like, year and a half sort of time. Hopefully next Christmas, maybe. All going well, Santa might be helpful. But yeah, there's plenty of work to get to that.
Probably some way kernel developers can help is if you have the short list of language extensions that you're relying on currently for unstable features, like having that as a short list somewhere, and then providing that short list to the folks working on the GCC implementations will go a long way, particularly towards getting probably maybe unstable features more stabilized, right? You know, it always helps having a second implementation take a look and kind of hammer out details and say, you know, these are the trickier parts of implementation or not. I think like inline assembler is one that I'm very curious about. Like I had seen something like one of the Rust features that would use like LLVM's pseudo language for like inline assembler, like that's not going to fly kind of thing. Though I think if we take like the more expected GNU-C extension for inline ASM and rewrite that into something different, like that might be a little tough sell to kernel developers, you know?
So yeah, so for the unstable features, at least for the ones in the kernel that we are using right now, which is still up in the air, so we can perhaps remove some of them. Some of the others are just nice to have. So it depends on which unstable feature we are talking about. What we have this list, I can share the link. Is the second issue in GitHub. 1 second. We have this issue that I will put in right now, and you will see, well, a lot of things. So don't get too.
Right. So Josh has a point that he's putting in the notes here. He says there's a project called Rocket, I guess. He says they used Rust nightly for a long time, but they kept a short list of nightly features they needed and specific reasons why, and that helped them kind of meet in the middle so that they're now able to build their project on stable Rust.
I put it in the chat if you can, because otherwise, just in case it breaks, if someone can put it in the share notes, so I don't have to switch the tab to the. So I put the link to the unstable feature we are using in the different parts of the language, etc., etc. Some of them we can remove. Some of them, yeah, I think we should have. Some of them we are trying to use only unstable features, or we hope. I mean, we are trying hard to only use unstable features in the abstractions, so in the subsystems, not in the leaf modules. Because the idea is that, well, even if there is something that doesn't get stabilized or is changed or removed in a feature version of the compiler, we can easily change that, and we don't need to change the majority of the code. But still, there is a couple of features that we use in the drivers as well. Yeah, so those are the features. And just to finish this slide, basically, please continue, or just to stop me, David, if you want to.
Well, no, I mean, thanks very much, Miguel, for this overview. No, and then the great discussion yesterday afternoon, and for, I mean, also this, having this wonderful session. As you mentioned at the beginning, there are these, Rust is evolving very rapidly, and there are, features that are stable or features that are unstable, and we definitely want to encourage. I mean, the two issues. I mean, one is just the communication, because we're not trying to create a different language. I mean, there has been a lot of history of GCC with the various extensions, but it's not a matter of trying to break Rust or take it over or to distract it. I mean, we definitely want to ensure that with this Rust, and then Philip and the team at Embicosm are very strongly connected with the Rust community. There's a lot of communication that we don't want to start creating a different language or having the Linux kernel use a different variant of Rust. I mean, there's no interest. So it's a matter of how we can ensure this communication, and that the GCC is not used as a vector to try to change the language or use something else in the Linux kernel, or as a creates tension between the Linux kernel community and the Rust development community. So I mean, so that's one, is to ensure, and hopefully the Linux kernel people will be cooperative with this, and be involved in not trying to sort of pit these implementations against each other. But also, just as you mentioned, how to encourage it, as I mentioned there, to have the Linux kernel developers and their corporations, their businesses to get engaged as well with the GNU toolchain development, because it's so important to the Linux kernel and the whole Linux ecosystem. So if to provide additional resources to help ensure that the faster that this GCC, I mean, both of these implementations are available and robust and ready, the faster that it's practical to have Rust inside the Linux kernel, and especially available and used by Linux distributions and the entire deployment mechanism, and ecosystem, the other way of describing it.
Yeah, I think like we discussed yesterday, anything we can do from the kernel perspective to help either GCC or we have, for example, one idea is the mailing list, the toolchains mailing list. There is not a lot of people, I think, in the toolchain. Nick, you can correct me if I'm wrong. There is only a few people in the toolchains mailing list right now, but we could invite both GCC developers and the Rust community as well, and the compiler folks from the main compiler, basically the current main compiler. I know because since you are working here, Philip, on that, I every time I say the main compiler, what I mean is the current main compiler. I'm going to get me wrong. So we could get people in that mailing list.
But the mailing list already exists, right?
Yes, it is already exists. I can share the link.
Yeah, we have to subscribe to that.
Yeah,
it's true.
Yeah. So there's only, I think, 9 people or 10 people only. So we should really increase that number and have folks from Rust as well. At least if we make it into the kernel, but they can already join. I think help us.
I'd be interested in joining that mailing list as well. I'd be interested to see what the conversation's like. I think I don't know if this is the right place to talk about this or anything like that, but the from one thing in my perspective down the line that I'd be concerned with would be the idea of language versioning. I know Rust does use Rust editions and stuff, but I'm not sure how that's going to work, given that Rust 2018 edition, then subsequent from that we have all the features that get added over time, and things like that. I'm not sure how that's going to work out, but at the minute it's not really on my radar right now, but it's something down the line that I will have to start thinking about how to handle that.
So on editions, well, there is also what is more concerning, I guess, is rather than editions, which I think they are supposed to be more or less easily forward compatible, not completely, but at least more or less should be easy to transition. There is also a feature like one we use already in the kernel, which is the unsafe operation in unsafe function, which is the one for not implicitly assuming an unsafe function body is an unsafe block. So you can have, so basically the idea is that you explicitly mark all unsafe blocks, even if they are in an unsafe function, because the concepts are orthogonal. And the concepts are orthogonal, and they in the language right now is not like that. So thank you, Mark, for putting that. So that flag, if you enable it, like we do in the kernel, which we deny it, so it's basically like W error for those that are new to Rust. We use W error for some warnings that are like for style and things like that. But this one in particular basically changes language, because things are not going to compile anymore in that variation of the language so far. So I hope we can also discuss with the upstream Rust to get that to be the main language in our future edition, because I think everyone agrees that it's a good idea to separate the concept, or at least a lot of people agree. So there is also the concern about like variations of flags to the compiler that basically make a split a bit on the language or the. And another thing we have is a document that we discussed yesterday also with David. You received because I looked for an email. You received, okay. We have a document with all these projects that are going on that we would need. It's intended for companies, so companies perhaps want to put some funding there, and we have a document. If somebody in the room is from a company or wants to support with funding, just let me know, and I will send you the link to the document with all the projects that we have.
Miguel, I wanted to ask or raise 2 questions that came up in the chat from Mark. One is asking about, are there currently any use of procedural macros in the Rust kernel patches? And then the other question is, does bindgen rely on libclang? The answer to that is yes, but can it be made more robust by relying on dwarf or CTF to generate Rust types, or are there features that rely on C header parsing, which feels more fragile than dwarf and CTF?
So sorry, Mark, I completely forgot to keep with it. So for the procedural macros, as you see here, this macros crate is a procedural macro. As you know, procedural macros are like separate. They are not like the Rust, the macros by example, which are more like the secret processor that is integrated in the same pass, let's say, or the same completion. I don't know how to say it, but basically it's like a completely different translation unit. It's like a compiler plugin. And in the official or in the main Rust compiler, these are like a shared library that the compiler loads after compiling it, and we do use them. For the GCCRS, I think we discussed, Philip and myself, this in one email or something. I think, yeah, we will need the procedural macros, I think, for some things. I don't think we want to skip on that. But it would be nice if instead of using a shared library or something like that, you could have something better than the main compiler, so that we could have procedural macros that don't crash the compiler if they
Yeah, as far as I know, the procedural macro thing is like a separate crate. So in theory, if we're able to compile that crate, we hopefully get the support for free, all going well. So that's my thought, because I know MRC had to do the same thing, and they had to make some slight changes to it, obviously, but hopefully we can keep those changes to a minimum, was sort of my thoughts on it so far, but we'll have to see when we get to that point, middle and start next year.
Yeah, I mean, right now we don't use a lot of procedural macros, but we could even do some fancy things on the procedural macros. Instead of doing something on the build system on like individual steps in the makefile, the kernel makefile, what we could do is have procedural macros that actually like create files and compile C files, generate, for example, the module macro, where we declare a kernel module. We could, instead of doing what we are doing now, which is basically a complex thing that I didn't really like it. I prefer that we generate a C file with the macros of C, reuse those macros so that we don't have to re-implement them in Rust, and then compile that C file that links into the rest. And that way we can reuse that. So for that, for example, we could use either an independent step, I guess, or a procedural macro. And a procedural macro would be better, because then it looks like Rust, it's Rust, and it's everything much easier, I guess. But then, yes, we need to create files from the procedural macros, and I don't know whether that's actually intended to be supported. Right now it works, right? But I don't know if it is, like, for example, if you create you put the procedural macros in an independent thing and in another process, and you sandbox the process or something like that, then those kind of things perhaps don't work. So yeah, there is some discussion there. But yeah, the other question was, does bindgen rely on leaf-clang? And this is one big thing, and yes, it does. Let me go quickly.
I think like one thought on that is it's probably much faster to parse header files than it is to have the compiler generate the debug info and then pull type information out of that.
Yeah, we also discussed that last week. Nick and also David Malcolm also told me to look into libABGate to perhaps do that. Because even if the question here is more related to GCC build kernels, because if we are building the kernel with GCC and we want to have everything built with GCC and not Nick's GCC and Clang things, either we need a bindgen backend that uses GCC somehow. We also discussed that. But the other idea is to, like Nick and David suggested, is instead of making this backend, or even if we use that backend, but have use at least a way to check that the EBI is correct. So instead of doing a new backend with GCC, we still use the Clang. We keep everything as is, but at least we know if the ABI is the same. So even if we are using a different parser, basically, we more or less know that the output is correct. There is also a question whether we could not use a binding generator and have the thing written by hand. But the problem is that then we have to duplicate all the headers manually. And then we also have to use conditional compilation, and we have to keep that in sync with the C side. And I think it's not worth it.
There's another question from Josh about discussion around unsafe function versus unsafe blocks. Their Rust compiler developers are considering a change in this in future versions, and it would be helpful to have feedback from kernel developers on this. And then I think in the chat there's also a note maybe about calling inline functions, which I don't know if you covered.
Yeah, so inline functions look like this. Yes, I mean, this is, sorry, there is not even time to, so sorry that it's a lot of things to discuss. So that's why we encourage you, if you're interested in Rust, please come to the meeting. We have monthly meetings, informal meetings, and also technical meetings if you want to follow the effort. But for example, for C macros that are not basically trivial, so basically a constant or something like that, we need to put them in a C helper that we call like this, like the bag macro, for example, in the kernel, and then we call it in a C file. And then that's what we generate the binding to from Rust. So that's what we do for But it's not a question for Bokun because Bokun knows about this already, but just in case to clarify. The Rust parser is written in C++, so we will have to translate the token stream somehow between C++ parser and Rust declarator. Yeah.
Sorry, Miguel, was there any feedback on the use of unsafe functions versus unsafe blocks? I don't know if you or Wedson maybe had experience with that.
We would really love that is in the main language, like this is the default in the language. So if we can do anything that we can help get that, our feedback, I think, would be, yes, we really want that because we want to put all the safety comments, we want to minimize the blocks, and that is required. There is some more churn in some functions, but I think when you are writing an unsafe code, you want to be explicit anyhow, and you should not be writing a lot of unsafe code. And therefore,
yeah, Josh is saying in the notes that it would be very helpful to have that comment on the upstream issue from the Rust in Linux project proper.
I think, okay, I will make sure to make, thank you, Josh. I will sure to make, I think I don't know, there is so many things we commented, perhaps I'm mistaken. I think we commented at some point, but I will make sure to review that. Thanks a lot, Josh. Because if we make that happen, it would be really nice, I think, for all parties.
I have a question, Miguel. What are some AVI-related issues that you've either run into so far or anticipate running into? I think that's one of the major things is like FFI sounds good on the surface, but no one can quite enumerate everything that goes into an AVI.
Well, we had some, I don't remember right now, but for example, even if it is not AVI, even binding can make a mistake. So there has been bugs, for example, in binding, which means a wrong AVI. So, and there is things that binding does not support, and we have to make opaque types and things like that. We have to basically whitelist or blacklist or deny, allow list the types, some of the types in the kernel. So we may face some problems later on if we need to actually access those structures from the kernel. That's one problem. On the AVI per se, I think it worked. When I tried to, we have support, but it's a completely a hack between GCC and Rust. So you can actually write now for some configuration, it works to build a GCC kernel and the Rust side with LLVM. And it works, it boots, it runs the samples, but it's very, very, it's a complete hack. So I don't think we want to support that in the long term. We want to either completely build GCC only kernels or LLVM only kernels. Yeah, sorry, I don't remember off my head right now, off the top of my head, any AVI issue. But for sure, for example, if we use the randomize GCC plugin configuration in the kernel, I don't think that would work because the binding doesn't know about that. I don't know if we have 1 more minute or anything. I think I have seen. Okay, well, let me go to the server.
Yeah, I think you have 5 minutes.
Okay.
Yes.
Let me see the server notes. If I missed something, please let me know if I missed anything. Otherwise, I can go back here to the top of the slides.
Yeah, there's a comment just raising the issue again about stable inline ASM support. And Josh is saying that's on track to be stabilized. I guess I'm curious personally which form that is, because I think I've seen like 2 or possibly 3 different forms of inline ASM.
Mm-hmm. The escape hatch I mentioned, going back to the slides just to fill the time while there is a new question. The escac hatch is this trusty bootstrap flag environment variable, that you can use to use a stable compiler with unstable features. But again, it is not supported. It is not intended to be used by normal projects. And this is just what we do in order to be able to build with a stable compiler. And we need it because of the unstable features I already explained. Which components are required to build? Yeah.
Sorry, another question, or maybe feedback, is I think the Rust project has done a really great job focusing on documentation and handholding and getting people up to speed and building a community around that. I think there's been significant feedback on the mailing lists that the prospects of learning a whole new language in the syntax, and the grammar, and that's before even getting to the borrow checker and having fun wrestling with that. I think just feedback for the project overall, something that might be worthwhile doing is putting together either a series of documentation or some kind of not meetup, but almost like a training class or training course or some kind of documentation that's writing Rust for kernel developers and showing people, like, I think Wedson's drivers are a really great first step into showing things kind of side by side. LWN did a really great job of kind of matching the lines up, like in a way that you can easily kind of see the difference. But I think like having some text documentation saying like, you know, we have things like attribute must check in C, but if you don't use it, blah, 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 versus, you know, if you have this monadic use of returning result everywhere, then you can use match and destructured assignment and the question mark operator everywhere, right? And then that's how you avoid this. Or, you know, we have attribute cleanup in C, but it's nice having a first, like RAII as the first class language feature. And here's how you can turn some go-to spaghetti into, you know, much more straightforward kind of code. And I think things like that would be super helpful for kernel developers.
I agree completely. Indeed, for what we did to begin with, we don't have the text so far. What we had already in Cangrejos, which was before the week of LPC, we had like a Rust. It was invitation only, but it was like a Rust. Sorry, what I call. So we got a training, so to speak, a bit of training on that, and I think we should expand on that, and we should also put some training. We are going also to have a mentorship series that Shua, thank you Shua for, I don't know if she's here, but she contacted me to have some mentorship series that on Rust and how to write Rust, etc., etc. So I think like mentorship or helping people getting up to speed is something that we will have to do, and especially writing some text. I have pending in the queue some documentation that is half written, and I want to upload it. And for example, more on coding guidelines, more how to write these things, how to write a driver, etc., etc. And LWN, I also want to point out, LWN has been doing a great job of putting some articles out this week, especially, and last week on Rust, and they are very, very informative if you want to follow along. And it explains also a few things. And I don't have time to read the chat, but very quickly, yeah. Jose, you plan to rewrite Linux assistant Rust? No. It's not a rewrite because we are using the C APIs, so it's not a rewrite. At least right now, nobody is implementing. Nobody is implementing a new subsystem Rust, but they are actually using the C APIs from the Rust abstraction. And with that, thank you everyone really for coming. Sorry that it was so, but I really enjoyed the discussion, and thank you Nick for having me here, because I know that in the beginning it was the only talk we had in LPC, but then we had all the others before, and now it's something that we like. We are a bit repeating a bit, but thank you for having me and everyone coming. Thank you.
Okay. Thank you, Miguel. It was very nice. Thanks. Okay, so the next activity is the support for ARM64 in Object Tool. So Josh, where are you? I'm making you presenter. Oh well, actually, yeah. Actually, I'm taking presenter back so I can put the right presentation, which is Object Tool. Oh, Will. Okay, there you are. Hello. Is your audio working? Can you? Yes.
All working.
Okay, so let me make you presenter.
Thank you.
And yeah, make presenter. There you are. Thank you.
All right, great. I'll just wait for that to propagate. That takes a while. Okay, there we are. Perfect. So yeah, thanks for having me. I'm Will Deacon. I'm an upstream kernel developer. I co-maintain the ARM64 architecture port with Catalin Marinas. And I want to talk about ObjTool for ARM64. I'm not an ObjTool expert. There are people on this call which are, so hopefully they'll be able to chime in. But I'm going to talk about what I understand of ObjTool and give an introduction, because some of you probably don't know what ObjTool is. And it's not a typo, it's not ObjDump or ObjCopy, it's another thing. So let's get cracking. So yeah, what is Optional? It's a host program shipped in so it's part of the Linux kernel source tree. It doesn't run in kernel mode. It's a host user space tool, and it's run during the kernel build, and it basically post-processes each object file that's being used to construct the kernel image. It's only currently supported and used by x86-64. It's been in the kernel for ages, since February 2016, I think. And it's a general binary linter, so it can check and enforce some invariants that we have on the VM Linux binary, well, on these object files. But it's also it's a patching utility, so it can also do some modifications that I'll talk about later. And it can help to catch issues potentially in the toolchain. So if the compiler has generated code in a way that we didn't expect, or if it had a bug, or if there's some assembly code that's not quite right, normally we'd miss those, and if we're lucky, we get some runtime bugs that we would be able to debug. But actually, spotting them early is really helpful. It does rely, for some of the things that it does, on being able to reconstruct the control flow by looking at the binary, and that can be sensitive to compiler optimizations, right? Because this is not looking at it doesn't have like the compiler IR. It's just looking at the binary. So here's a commit which actually disabled global common solid expression elimination for, I think they tried to do it for a function and to do it for the whole file, because actually GCSE was breaking the control flow in terms of what Optional expected. So more on that later. I've got an example of how that happened. So on x86 specifically, what does it do? So three broad classes of things. And please, people who know more about Optional, interrupt me if I get any of this wrong, because like I say, this isn't my area of expertise. But it does three rough things. So one, it generates this awk unwinding data, which is a lightweight alternative to dwarf. It's extra information alongside the binary sideband information, which can be used for doing unwinding without the need for frame pointers. So it means that you don't have to pay potentially the runtime cost of having a frame pointer, but also it means that you've got more robust unwinding because, for example, handcrafted assembly code doesn't have to mess around with frame records and stuff like that. So that's really nice. And it also actually, I'll talk a bit more about it in a minute. It offers some additional features for cases where you can't actually unwind using frame pointers. It performs binary validation of stack frames. So if you are using frame pointers, it can check that actually your records look correct. And I think it also checks some of the awk annotations as well with things like alternatives. But it can check those. And that's relied upon for live patching. So live patching is where we're going to be patching the kernel at runtime. And we want to have, well, we need reliable backtracing for that. So, make sure, the function you're patching isn't in someone's core chain, for example. And other things that it can do, it can point out if you've got unreachable instructions, it can check that you're not using indirect branches, which might defeat the Spectre mitigations, Repline on x86. It can check that functions which are not supposed to be instrumented with things like sanitizer calls really aren't instrumented. So it's generally, just checking invariants on that binary. And it can modify the binary, as I mentioned. So some of the things it can do, I've mentioned at the bottom, it can convert sanitizer calls to NOPs, because I think there are some cases where even if you say, I really don't want sanitizer calls emitted in this function, sometimes they can be emitted for various reasons. So it can spot any of those and knock them out. It generates a couple of ELF sections for things like ftrace and static calls, which are sort of kernel-specific functions where it's easier to generate the ELF sections this way than to try and construct them via basically scripts. And it can do arch-specific branch patching for things like insertion of funcs and trampolines if it's required. Peter, do you want to say something?
Yeah, so the sanitizer thing was basically some GCC versions not having a function attribute to turn off the sanitizer.
Okay, so it's not a bug, it's just they were missing the functionality.
Which is arguably a bug, but yeah.
Okay, but that's the kind of thing that, rather than say we have to now require a new toolchain version, we could continue to support the old toolchain version because Optional could step in and do the job. All right. So why do I care about this? Like I said, I don't know anything about Optional and I'm an ARM64 guy. Well, I've been unwittingly dragged into it. And here's some examples. So Ben H saying, hey, I'm looking at what needs to do live patching on ARM64. So that's going to require this sort of reliable stack trace. And Julian actually posted an RFC a while back for adding the base support. So there's interest from companies and the community to have this working. And why? Well, mainly we want the reliable stack tracing for the same reasons as x86, primarily for the live patching and the unwinding. And one thing that I touched on earlier is that it offers increased unwinding capability over frame pointers in the sense that you can unwind now across asynchronous boundaries, across exceptions, which is not always possible with frame pointers if, for example, you take an exception while you're constructing the frame record. But having said that, so it's sort of similar motivations to x86, but some of the constraints don't apply. So we don't have rep lean, we don't have a static call table, and frame pointers, okay, although they can't do this asynchronous unwinding, by and large, they're sufficient on ARM64. They're quite cheap. There's not much of an overhead just because we have lots of registers.
Don't you want to have a static call table eventually?
I don't know. I mean, I'm not sure that we...
I guess I love it. Is static call or are indirect calls any less expensive than just a direct call?
We don't, because we don't have the rep lean.
Right, that's true.
Our indirect predictors tend to be reasonably reliable. So it might still offer some performance, but I think we would need to do that analysis from the start to see if it's really worth it. I don't think there's no reason why it couldn't be. I think Ard was even talking about he might post.
Yeah, Ard has patches on the list to do the really basic form where you just have an indirect shim.
Yeah. But anyway, I'm saying that we don't necessarily require it, so it's not a reason to do Obstacle. So what we could do potentially, so like thinking about, okay, what do we want? Well, maybe we could just start off. We could just have the linter. So we say, okay, we're not going to have any awk initially, and we're not going to have any patching. We could just say we're going to have it as a binary linter to make sure that the binary is as we expect, and check our frame pointer stack records, for example. But I think two things happen if we only enable that. One is it won't be very long before it finds a problem, and then second, people will then be inclined to enable the patching mechanisms in Obstacle to work around those issues, because it's easier to do than trying to fix a tool chain or trying to change lots of code. I would argue that the control flow failures, like the failures to track control flow in Obstacle, which I've got an example again, but the FGCSE thing, I would argue that's an Obstacle bug, and we shouldn't be disabling compiler optimizations for that. But that's actually a pretty challenging thing to fix in Obstacle. It's really not designed to have that level of analysis of the code. So it's easy for me to say that, so I put it in red. But it feels wrong to turn off compiler optimizations to make this work. And I don't know how well that scales either. So perhaps one way to fix this, and I'm asking how feasible it is, would be, could we do some of this stuff in the toolchains instead? Potentially having another program maybe like Obstacle, which is part of the toolchain, which takes in not just the object files, but also perhaps the IR from the toolchain, something like that. Or even having options to the compiler to help us out with potentially generation of awk, for example. I don't know how much appetite there would be from toolchain people for that kind of thing. Sorry, Sega.
Hi. If it's possible for the compiler to do asynchronous unbinding, right? We already have an option for it.
Can you put
you're very quiet.
I can't
You're
hear
very quiet. I couldn't hear what you said. Sorry.
Oh, sorry. GCC already has an option to do asynchronous unbinding. It uses the dwarf info for it. And it's the only way to do any unbinding on many architectures, actually.
Yeah, so I think the problem with dwarf, I think the kernel did have a dwarf unwinder for a while, and it was just it's very, very complicated, right? You have to have an interpreter that runs, and it was just full of bugs. It was very unreliable, and it got reverted, I think, by Linus.
Wasn't it also huge?
Yeah,
it was like Orc is so much smaller.
Right.
Yeah.
Right.
So the dwarf unwinder, it was large, it was buggy, it was unreliable, because then the dwarf unwinder would crash, would take the whole down while you were trying to stack trace. It was slow. It was dreadfully slow.
Yeah, and also we had to have annotations throughout all the assembly code, and those were often wrong and outdated.
Yeah, you need CFI directives all over the place, right?
Right.
Right. So I think there was a GCC plugin posted as part of the AR64 patch set. So I think the thing I would be curious about is actually having some kind of formal specification of like what needs to be provided by the compiler here. Like, to me, I'm always curious. I think the GCC plugins are interesting for adding support to released versions of the toolchain that we still want to support. But I think, like, I would encourage people to take a serious look at, is it feasible to implement in the compiler proper in the first place? And how can it be generalized for other projects than just the Linux kernel. So like having a formal specification of what would be needed by the compilers, I think that would be a good start for compiler vendors to then, sort out and argue it out and come to an agreement on how to provide something that's maybe more generally useful to maybe other projects that might have similar problems as well, kind of thing.
Yeah. So the one thing that came up a few times is an informal ABI to do the jump table thing and make the control. Because on x86 we must get our way around detecting where jump tables are, but the ARM people can't. They just could not find the jump tables just from the object file themselves. So that's what they needed the GCC plugin for.
Yeah, in general, it's completely impossible to reconstruct control flow from a binary.
Correct. So some help there would be very, very nice.
This was the example you gave to me, Peter. I think I just put it in a slide because it's very simple to explain, right? Where we have two conditions. So if conde, then we set this is just sort of pseudocode. We set 2k equals 1, assume it's 0 initially, and then later on we say, hey, if not 2k, do something. And Obstacle will consider the path where both the conditions are true. And then it can assert all sorts of things which are not reachable in practice. So that's a simple example of, Obstacle doesn't really do any tracking of values, but it doesn't do it at all. It's even simpler than jump table stuff.
I do want to say with this example, this particular example has not actually been a problem in practice because OBJ tools mostly just worried about stack layout changes. Those tend to only happen in the prologue and the epilogue. So going down an impossible path like what you see here doesn't, usually doesn't produce any false positives. But like Peter said, the main problem we have is just figuring out, jump tables. But everything else has been good enough. Obviously OBJ tool can't do things, figure out things, exact control flow, but it figures out most, all possible vectors of control flow. It's been pretty good at doing that. It's just the jump tables have been the major problem.
Yeah, so I remember running into some of these things, but yeah, mostly we can work around them, but it's annoying.
Is this like both compilers? We can't figure out the control flow from jump tables?
So x86 has been really difficult for, GCC came first and we put a lot of effort into that. And then it mostly worked for Clang, but, even Clang has some issues because there are some undefined, jump table vectors that that normally aren't used, but OBJ tool is not smart enough to figure that out, right?
Yeah, I got to fix those up. That's on the to-do list. But I'm curious in the AR64 case, I'd be curious to see a description of the problem that actually has like godbolt links and disassembly from the two compilers and shows this is what the jump table looks like in disassembly, and this is why it's ambiguous and why we can't figure it out. Because to my understanding so far, we've just had people say, oh, it's broken or it's hard to figure out kind of thing. But I think having actual disassembly would make it much clearer kind of the problem.
Well, the main problem really is it can jump to anywhere in memory. The size of the table, the jump table, is not constrained in the way the code is generated. You cannot see if you're jumping somewhere outside of the table. So you could you can at the same time make it work with object tool and make the code safer by doing some sanity checking in there. That you're only jumping to valid switch cases.
I think the high level takeaway here, though, is that whatever we do for jump tables specifically, that's fixing one case of fragility due to compiler having the freedom to generate code, right? And what we're really worried about is as compilers generate code in different ways going forward, which they will just because optimization passes change and whatever, this will inevitably become fragile again in a different way. And I think the higher level thing that we're trying to figure out here is how do we deal with that in abstract? Is that at all possible? Can we sidestep the issue entirely?
Well, you will probably have to use the asynchronous unwind info that GCC generates. But then you probably want to translate that to some other format that doesn't have runtime problems.
Yeah, so I think for us, all we really need on ARM64 to do unwinding correctly is to know when we need to start from the frame pointer or the link register, because our procedural standard AAPCS64 gives us relatively strong guarantees otherwise. So the information we need is a lot simpler than what's in those unwind tables. I don't know if there's a good way of extracting that, or if that falls into the same problem as we're trying to extract things from the code, in that the format of it might change, or the structure of it might change in a way that we're not expecting.
I would like to mention that the CTF people, they are right now designing extensions of the format, of the CTF format for version 4, and one of the things they are discussing is how to include simple unwinding info. And they are targeting x86 and also AR64, ARM64.
I thought it was just supposed to be type info. Now we have dwarf all over again.
Yeah. Well, hopefully not.
Well, I will say that one of the benefits of OBJ tool is it treats the object file as a black box. So we need to be careful about trusting the dwarf or anything that comes from that. That's one of the main benefits we had from ORC, was that it was dwarf independent, and we kind of independently verified that that things look sane.
I think that's a good point, right? Because the reason that we would want this is to get reliable stack tracing for live patching. It's not, although it's great for debugging, it's not really debugging that we're talking about here. And if we enable this and actually we can tune the dwarf somehow and it's not reliable either, we haven't really solved the problem. We just have a whole load of complexity where before we didn't.
Right.
So could we at least use this unwind info to help Object to make sense of the binary? I mean, even though we don't use it at runtime, it could use in places where you actually run into these issues where you can't figure out what's going on, and maybe use it just in those places and not use it don't ship it, don't use it at runtime, don't do anything else with it. Would that make any difference?
Yeah, that might actually be an interesting approach. For finding the jump tables and the jump table vectors, that might be something to look at.
I think that's probably all I had. Let me just double check. I think the next slide was just, yeah, okay. That's all I had. Not really sure what the next steps are here. Like, to me, feels like this stuff should be coming from the toolchain and we shouldn't be having an extra tool. But I don't know. I'm not an expert on it. So
I quite did not understand why would you not trust dwarf. I mean, I understand that it's not the ideal form, of the information that you will find useful, but why would you not trust it?
So I think there's two aspects to dwarf, right? So it's the dwarf information itself is produced, as far as I understand, primarily for debugging. So it may not always be entirely accurate. We're using it for live patching, and it needs to be 100% accurate. Otherwise, the machine dies. Then the second aspect, which I think is the important point, is the unwinder needs to be in the kernel and run, in kernel mode with privileges at runtime. And our experience has shown that running a dwarf unwinder in kernel space it's not a good idea. It's very unreliable. The kernel crashed. It tries to do a backtrace because it's crashed, and then the unwinder itself crashes, and you get no backtrace.
Right. Well, that's one of them. I mean, someone mentioned that CTF is becoming dwarf. Actually, it is not, because the motivation for adding unwind info to CTF is actually for other big program, which is not the kernel, but we understand that it's not convenient to have to implement a stack machine, right? Just to, for example, to evaluate the expressions to find the locations of the of the stuff, right?
Yeah.
So
Yeah.
it sounds like a common goal.
And another issue with Dwarf is the annotations required in the assembly. They were invariably wrong, and an object tool figures that out all by itself. We don't have to annotate our assembly.
Well, it tries to figure it out, and it cannot always. That's the problem.
Only for the jump tables.
Well,
That's the one you found so far. Yes.
I tried writing CTF for whatever it's and in assembly, and I always got it wrong. I could write orc annotations about it it's much easier. Which, by the way, it's just real quick. I have to jump off here, but real quick, do we actually have a orc specification somewhere that actually defines everything about orc, or is it just read the code?
There's some documentation, but it's not really a specification. So yeah, it's pretty much read the code.
So should we work on getting a specification for orc, make it more formalized?
Yeah, I think that'd be a good idea.
I think one other question.
Yeah, I'd certainly be happy to review that to make sure that it can work for different architectures, because I don't know if there are any x86 specifics in there, but you never know.
But that was what I was about to say. The question there, is there one orc or is there a per architecture orc?
Right, it's only been implemented for x86, so it's not really a standard.
Yeah, you always find interesting questions with the second implementation, right?
Exactly.
That's why I created ftrace. I did it on 2 architectures at the same time.
Okay, so I think we're probably done, actually. I don't know how much time we had. I've lost track.
Yeah, I think
4 minutes.
Yeah, there's 4 minutes, but we could probably start with the next talk if they're ready to go. If there's no other questions for Will. Thanks very much, Will. Thanks for the discussion, everyone.
There is a raised hand. Andreas.
Yes, one quick question. So regarding these comments about the difficulty to reconstruct the control flow without having any dwarf debug external data about that, wouldn't that also cause issues for user space live patching, or are we facing specific issues here that only apply to kernel live patching?
So I'm not like
with regards to the proposal on the current slide of having kernel-specific compilation flags, I just wonder whether we may just need compilation flags in general as opposed to something that would be exclusive to the kernel.
So I think in user space, is dwarf just used for, because you can do asynchronous unwinding with dwarf, as I think.
Yeah, dwarf is pretty common, at least in user space, I feel like.
So perhaps I think in user space, dwarf is probably more appealing than using it in the kernel. Because if it doesn't work out, you don't kill the machine.
But isn't it what C++ also uses for its exception handling? It's not just for debug, right?
Yeah, on ARM, I remember looking at this before. On ARM, there's all sorts of different tables for C++.
I think the exception handling frames are different from dwarf proper.
What is normally used with GCC is lib unbind, which is GPL plus exceptions, so everyone can use it. And it can parse everything, and it just works on every architecture.
Right, so
but
there's...
for some reason, the kernel re-implemented everything, and obviously not correctly.
Well, there's also places that use, a different dialect of C++ that'll say F no exceptions, and then they don't need to link against lib unwind, and then everything is like return code based programming instead of throwing exceptions and stuff.
Yeah, the control for the kernel is also not traditional. I mean, for exception frames, we have alternatives, we have a whole bunch of weird stuff. Mostly done in an assembly, and then the code says, oh, nothing about that. But if you want to unwind properly, you need to know about all that.
I think one. Oh, sorry. Go ahead, Mark.
After you.
I was just curious if maybe we could follow up afterwards, Mark. If you could explain a little bit more about the asynchronous unwind issue that you mentioned between using the frame pointers versus, I think you said the link register. That's something that was.
I actually have slides on that. I'm not sure if we have enough time to go over it now. but we can do that in a hack session.
Well,
it's
actually we do, because now there is only 1 minute more for this activity, but now we have a break of 15 minutes. And I can't think of any reason why we could not use the time for discussing about anything.
Yeah, Mark, can you have those slides ready to go?
Yeah, I mean, if Will can, if someone can make me the presenter, I can do that, because I've not, unfortunately, I haven't uploaded the slides.
I think you need to upload them somewhere, I think.
No, you can upload them directly here if you get presenter. I mean,
okay, I'll assign it to Mark then, if I can do that.
Mark Rutland, make presenter. So now you must be presenter. Now you can upload stuff.
Oh God.
The blue plus button at the bottom left. Manage presentations.
Oh, I'm trying. My computer is actually acting up quite substantially. 1 moment. I'm unfortunately trying to do this from a Mac, and PowerPoint has crashed, which is always a plus.
Well, I hope anyway, it's M1 at least.
Yeah, so blue plus button, upload presentation.
Reminding to everyone that the theoretical break ends in 15 minutes.
Processing, and oh, there it is. So yeah. So on ARM64, our calling convention is called AAPCS64, and it's on this GitHub page if anyone wants to go into the fine details of it. Big deal is that function calls are made with BL or BLR, which is branch and link register. These instructions atomically put the return address into the link register, which is just a general purpose register, also known as X30. And the return instruction just consumes that value, leaves the register as is, and is basically an indirect branch back. So it's the callee's responsibility to actually save and restore this onto the stack if necessary. And the compiler decides the compiler decides if it's going to do so at all. So like leave functions, it might not do it for it. It decides when it will do so. So it might have a prefix of the function where it doesn't actually bother creating this frame record. It decides where it will create it. So it decides exactly where on the stack it will place. The procedure call standard doesn't say that. And it decides exactly which instructions it uses to create the frame record. So we don't know, we basically can't discover it other than by following the frame pointer. And we can't identify from a program counter alone whether or not the frame has been created yet. And the PCA says that the LR and FP are defined at function boundaries. So when a function is entered, the LR is the address it should return to, and the frame pointer points at a frame record created by its caller. But then within the body of the function, you've got this gap between entering the function and creating a frame record, or potentially not creating a frame record at all. So if you take an exception in the middle of the function, you don't know whether you need to start unwinding from the LR or from the FP. And possibly an example will help. In this block of code, when we enter the function foo, and the PC is pointing first at this store pair instruction, we need to unwind using the LR. Then as of the next instruction, we still need to unwind using LR, but as soon as we get to the BL here, we've already created the frame record, and so we should start unwinding from the FP rather than the LR. And when we go and call this function bar, and that bar returns, the link register will be pointing back into foo. So we definitely don't want to use that to unwind. We get a little bit further, and after we completed this load pair here, we've actually restored the original link register and frame pointer, and so we want to unwind using the link register again. And then we do the rest, and that just consumes X30. So the big problem is we need to know where we are in the function and whether the LR is actually this function's return address or not. We simply just don't have that information. And because there's so much freedom that the compiler has as to how it pushes all this, we can't guess via heuristic or anything like that. Does that help, Nick?
Yeah, no, I think it's really helpful. I'm just like picturing a giant lookup table, like the fix up exception table that we have, where we say for each instruction, you know, should like which of the two registers should you be looking at?
And I think in theory, at least, I'm not sure the procedure call standard says whether or not these are created atomically. We currently assume they are, but I think that's something that Clang and GCC both ensure at the moment, and I think it's kind of understood that that has to be the case.
And there's like a recent discussion around one of the GCC plugins for the shadow call stack that pointed out that there can even be quite a few instructions, I think, before setting up the frame pointer here.
So for example, with shrink wrapping, you can have this early prefix where you have an early return, and in fact, you can have like a branch table, a jump table here that jumps to multiple things, each with their own stacking and unstacking. And like in the worst cases today, you get this horribly long prefix with our branch target identifier, some stuff for patching, potentially jump tables, and then various bits and pieces here. So it gets very complicated very quickly.
Just as a note, can you send either Jose or I these slides, or we'll try to figure out how to attach them?
I'll attach them momentarily.
Cool.
To the...
And then I'm curious on that very first slide, can you maybe annotate it a little bit and just say, like for each instruction, which register should be looked at, kind of thing?
So for this example?
Yes. Yeah, I think what you said out loud was incredibly helpful. And for anyone seeing the slides in the future, it would be super helpful to have that annotated.
I agree. I'll see about adding slides for that then.
And I'm curious, so what happens today then during an unwind, like a panic or an exception or something? Like,
so for regular unwinds for a function called boundary, we can always do the right thing. But across an exception boundary today, we always start using the link register. So actually, sorry, we start using the PC and the PT regs, which we know is absolutely the thing we interrupted. Then we use the LR, and then we start unwinding the frame records. So that LR value can be, but it can be a duplicate of what's in the frame record. It can be something bogus because it can be, for example, the return address of this BL.
Yep.
Yeah. Or it can be differently bogus because the foo is perfectly permitted to use the LR as a scratch register transiently, for example. So we overestimate today, which I understand might be okay for reliable stack trace, but it's also a bit concerning. But it's generally confusing.
And I'm sure that's frustrated debugging efforts where a stack trace versus the program counter haven't necessarily lined up in retrospect.
Yeah, so I think that there's a trivial thing that we can do, which I've been meaning to do for the last few weeks, which is to like explicitly add an indicator that this may or may not be valid to the printed trace, but it's still not ideal. I'd very much like us to be able to unwind this reliably if we could.
That's a bit like our gas unwinder.
Yeah. So actually, as a higher level thing, I'd also like the format of the unwinders to become unified across architectures at some point. But I think that's a much bigger story. So the output format of the stack trace, stack dump code, whatever it's called. Right. I guess we can head to the actual break now then.
Yeah, I suppose just before we do, what are the follow-ups here then? So you're going to upload these slides so people can see them for reference. I think there was some talk about trying to write down not quite a spec, but like something about awk that isn't just code. And I'm not sure. Didn't hear a lot of screaming, but I'm not sure we've got much of a conclusion on what the next steps are for supporting this.
I think.
I think there was an idea to, there's an idea from Ard to read dwarf or the EH to find the jump table information.
Right. Yep.
That sounds like if I upload these slides and talk with Nick, maybe we can get something out on the list that better explains the specific problem I think we're trying to solve here on ARM64 for unwinding, and then maybe we can evaluate what the options are from that.
All right, sounds good. I mean, what we really want is the next time someone shows up on the list with obstacle patches, it'd be nice to have a response rather than just not review them, which is what seems to have happened at the moment.
I agree. Yeah. Okay. Do I need to do anything to give up presenter mode? Or...
Okay, thank you. So now we have 7 more minutes of break. Okay, I see we have the presentation materials for the Bolt talk in Indico already. Thank you, Maxim.
Ian just CC'd me on a internal bug report from our production kernel team. Someone's not using Orc Unwinder and they're hitting the same problem. Paul, if you're around, do you want to do a quick mic and video check?
Okay, so the next activity is the report for the standards committee.
Maybe
Hi, Paul.
Maybe I should put my headset on so I can hear you and so you can hear me.
Yes, your sound is perfect. Okay, so let me load your presentation materials. It's this report from, and let me make you presenter. Here you are. All right.
Okay, there I am. I've got the
Thank
little
you.
thingies on the bottom now. All right. So are we ready to start or we wait a few minutes?
No, yeah, please go ahead.
Okay, great. This is just kind of a summary of the things that have been happening in the standards committee from a concurrency standpoint for the most part. There's a lot going on, and this is just a subset, but we have to start somewhere. If I get my focus into this thing and then hit page down, maybe something will happen. These are the topics I'm going to cover at various levels of depth. We'll get as far as we get in the time we have. If you have questions, please either turn your video on and yell them out or type them in Matrix, which I'm just now opening. Okay, so starting with concurrency TS2, technical specification 2. There was a concurrency TS1 that had some updates from C11. I'm not going to get into that. That's in the standard by now. Concurrency TS2 is in the process actually of starting. In fact, it's just in June. It now has hazard pointers and RCU in it. These are C++ versions of hazard pointers. This is C++ technical specification. We expect symmetric fences to show up fairly soon. And sysmem barrier in the Linux kernel is an example of an asymmetric fence. It's a thing where you can use a compiler barrier and have it be, in effect, promoted to a full fence only when needed. All right, only when an update's happening. If things go normally, these would not make it into the standard until C++ 29. That is 8 years from now. With some luck, we might be able to make 2026. We'll see. The little URLs at the bottom are the working papers that talk about things. I won't point them out unless there's something special, but there you have the hazard pointer and RCU working papers that feed in to the technical specification. The technical specification itself will be another paper. I'm just going to talk about RCU. Meg and Michael could tell you about hazard pointers. There were some adjustments. This is not exactly like in the Linux kernel. For one thing, the Linux kernel is C and C++ is C++. There are some changes. They wanted everything prefixed by RCU, so it's not synchronized RCU, it's RCU synchronized. There's no such thing as an RCU head structure. Instead, there is a template class called RCU object base, and you inherit from it. So, doing things the C++ way. One of the things that I pushed back on hard was a non-intrusive. They don't call it call RCU, they call it retire. A hazard pointer also uses the word retire, so it is consistent between the two deferred reclamation schemes. One way to think of the difference, RCU is kind of sort of a weak reader-writer lock, and hazard pointers is kind of sort of an efficient and a little bit different reference counter. So different in our experience, Megan and my experience, if somebody's heavily using reference counters, they probably like hazard pointers. They're heavily using reader-writer locks, they probably like RCU. There is quite a bit of overlap. So for example, for example, there's things like RCU ref that kind of is a reference count in the Linux kernel because we had RCU to start with. And Peter is quite right. What we use in the Linux kernel isn't C as such, and it's certainly not standard C. I don't know that anybody uses standard C. It's hard to get anything done with it, but a dialect of it. And that's true of every large project. They're using a dialect of whatever language they say they're using. All right. So what happens with a non-intrusive retire? You don't inherit from RCU object base. Just as with single argument KV-free RCU in the Linux kernel, you don't have an RCU head in your structure. Instead, you just invoke the function and pass the pointer to it. And then what happens is there has to be an allocation, or this is what makes it safe in the Linux kernel, or if you do a mild attempt at allocation, then and it fails, you just call synchronize RCU and then just free it afterwards. So if allocation fails, you still have a way forward. In C++ world, things are a little different. What happens is there's a lot of applications that if you run out of memory, game over, they just abort the application and start it over. So, you know, they don't care. They just take it in the shortest go. And presumably embedded applications using C++ and RCU, if there are any, could do a strategy similar to Linux kernel. Let's see here. We've got lightweight. That looks like some things there from the previous session that I don't understand the question. Paolo asks if we can have smart pointers that forbid delete until you synchronize RCU. I guess I'd have to see more detail on that. It is certainly possible to have what people do in some cases. In other, I haven't seen this in the Linux kernel, but what they do is they have kind of a combination of reference count and either heads or pointers or RCU. And what happens is the reference counts just count the incoming pointers from the data structure itself. And what happens is when the count of incoming pointers goes to 0, then you do call RCU on the structure and everything it points to. Maybe that answer is not, you know, send me an email or we can get the question in more detail so I can understand what you're asking. Peter, I think, said the same thing I did, more or less, close enough anyway. Okay, so another difference in the Linux kernel, what happens is we have a grace period K thread and we have soft IRQs, and if you configure it that way, we've got RCUO K threads, all of which do RCU work off on the side, so that the main user thread that does call RCU doesn't have to do anything, really, aside from call RCU. There are embedded applications that use C++ that don't have a soft IRQ, and they aren't going to spend another thread. And so what we had to do, very reluctantly in my case, was that retire can invoke old callbacks. Obviously, it can't invoke the callbacks that were just posted, but it can do the old ones. This is annoying because there are certain deadlocks that can't happen in the Linux kernel. The Linux kernel is perfectly legitimate to hold a lock across call RCU invocation and then acquire that lock in the callback. That won't be something that is portable in the C standard. I've been arguing we should have a quality of implementation that allows that without deadlocks, and I'm getting a lot of pushback. We'll see how it goes. The main difference, though, is that they have resource allocation as initialization style readers, and C++ does its locks this way as well. And Paolo, you're quite right. It's a lot like defer RCU. And what defer RCU did is it had its 4K buffer it stuffed pointers into, and then when you filled it up, it called synchronized RCU and did them all. Okay, fine. At some point you have to give people rope rather than arguing they won't need it forever. Sometime I'll have to ask you what problems you came across with defer RCU. Probably the latency when the synchronized RCU hit you would be my guess. All right. Anyway, the thing is that what happens is that by default you just say, hey, here's an RC reader, and it disappears in the scope. However, there are mechanisms to allow you to make the reader stop and start and end as they would if you had an explicit call to RC read lock and RC read unlock. Okay, the deadlock. Yep. Okay, that's my main concern. Okay, Peter, I haven't seen the RII extensions with GNU. I'll have to take a look. Allocation fails, wouldn't work scenarios like I described yesterday where you have nested read lock and update. And Wetson, you're absolutely right. It is, in fact, what the rules change. If you have call RC, KV free RC with 2 arguments, where you're giving it a function to call and you're giving it a pointer and you're also giving an offset, then that works fine, and you have a RCU struct in the structure, and you can call it inside a reader. Okay. In contrast, if you're giving only 1 argument, and that's just the pointer, there is no RCU head, then it is illegal to call it. And Locktip will yell at you if you try. It's illegal to call it in an RCU read side critical section. You can only invoke it with a single argument in a context where it is legal to sleep, and that is not within our RC reset critical section. That's an excellent point, and that is something you have to keep in mind when you're using KV-free RC with a single argument. Okay, going ahead. Let's see here. Okay, I missed in any case, there's going to be a CPPCon presentation on this. Meg and Michael and I will be talking about the hazard pointer RCU aspects. Michael Wong will be talking about some of the process and other things at this CPPCon the week of October 20th. So cppcon.org, shameless plug if you're interested in more details on this topic. Failing that, we have Lifetime End Pointers app, which includes zombie pointers. And it turns out that there are algorithms that have been known since 1973 that intentionally access pointers to lifetime ended objects, and in some cases actually dereference pointers to a lifetime ended objects under certain special conditions. The problem is that ever since C was standardized in '89 and C++ a few years later, it is at best implementation specified what happens if you even access a pointer to an object whose lifetime is ended, let alone dereference it. And I've listed some different ones that talk about that. There's a couple of working papers on the bottom that go into painful detail on all of them. What I'm going to do is I'm going to talk a little bit about LIFO push. That's kind of like Triber's stack. Meg and Michael did some software archaeology, and he found a reference to LIFO push I'm going to describe in 1973 in a patent application. The patent wasn't attempting to patent LIFO push. It was just saying this algorithm exists. We don't know who came up with it or when they came up with it. We just know it was at least before 1973. 1973 happens to be the first year I used a computer, so there you are. Okay, so here's kind of an outline of the algorithm. That's very simple. If you can push a single element or you can pop the entire stack. All right. To push a single element, you allocate and initialize the data fields, and you do a repeat until the comp exchange succeeds. You initialize the next pointer to the current top element, and use compare exchange to try to point the top to the new element. And the compare exchange will fail, for example, if somebody else beats you to the push, in which case it fails. You can, in some cases, make comp exchange update the next pointer for you. Otherwise, you have to load it again. You just keep repeating until that works. So pretty simple comp exchange loop. Allows you to atomically push a single element concurrently with a bunch of other people doing it. You can pop single elements, but to keep it simple, we just pop the entire stack. Because to do that, it's just a single exchange. Do an atomic exchange, push null in there, get the pointer back, bang, you've got the list, and the stack is now empty. Okay, so given this, let's take a look at the pointer lifetime zap issues that this shows up. So we have list this initial state. The things are labeled red when it's unsafe to touch them because somebody else might be doing things with them at the same time. Okay, so red just means somebody else might be messing with it. And so the initial state, we got a stack that's got A on the top and B underneath it. The next thing that happens, the line between them is kind of faint here. I apologize for that. But we're going to push C onto the stack. So we initialize, we've allocated C, we've initialized. It's green because nobody can look at it in any way, shape, or form. And its next pointer is initialized to the current value of the top pointer. So it points to A. Okay, well, about that time, somebody else comes along and yanks the stack, the whole stack, does a pop all operation. So now C's pointer points to nowhere. It points to the, I mean, if they freed up they popped the thing, did something with them and freed them all. C's next pointer points to the free list. And in C parlance, this is an indeterminate pointer. C++ calls it invalid pointers to be different. And in any case, the pointer is to a lifetime ended object. And by the rules of the standard, this pointer is now plutonium. It is bad to even touch it, let alone do anything else with it. You aren't even allowed to load it, store it, or do arithmetic on it, except in very careful ways where you treat it as if it wasn't a pointer, if it was just bits. For example, you could cast a pointer to the pointer to a pointer to char and then access it, something like that. But you can't access it as a pointer. And clearly at this point, it's bad to dereference it. So here we are. Okay, about that same time, somebody else, we've still got this thing, somebody else pushes an A prime, and A prime happens to have the same value, or the same address, excuse me, as A did. So it's the same chunk of memory, but it's a different element. And now that next pointer from C happens to point to something that's type compatible, but it's still a pointer to a lifetime ended object. And so we call this a zombie pointer. It's kind of back from the dead. If you're working in assembly language, it'd be just fine. The bits are just great. It points to something that's type compatible. Life is great, but the compiler considers it to be evil at this point, invalid or indeterminate, depending on which language you're in. Okay, so next, if we were in assembly language, you could just complete the push like that. And in fact, we can do that. There's nothing wrong. We're doing a compare exchange not on the next pointer, but on the top pointer. And so we end up with this list now where the bits in the top pointer are just fine, but the top pointer itself is invalid. And this is something that compilers hate. This algorithm has been around for a long time. It's been around for longer than either the C or the C++ standard. Every time they complain about it, I tell them that they really need to deal with existing practice. They don't like that answer much, but hey, here we are. The goal is to deal with this somehow. This, of course, is one example of undefined behavior, which is the worst case what happens when you mess with a zombie pointer. There are some interesting, ugly things with undefined pointer behavior. UB can backpropagate. If you do something that's undefined, that can cause your program to do strange things earlier. The standard allows this. And that makes, if you have a mistake that causes undefined behavior, it makes it kind of difficult to debug, which is something that there's some shouting about going on about the committees about supporting debugging. Of course, the guys that are heavily into optimization, the guys who live to produce optimizations that make spec int go a little bit faster, love undefined behavior because they live to find another nook and cranny of undefined behavior they can exploit to make spec int go a little faster. I'm going to give you an example that is similar to one presented by an anonymous academic in 2007. And the thing is that if we had some intervening code that set I to the value 5, then it might so happen that A of 5 in assembly language was in fact the value I, and that could set I to 5 if we had undefined behavior. If we allow undefined behavior to backpropagate, then that could result in I actually having the value 5 when we came time to dereference it. And so we have a situation where this potential not really existent virtual undefined behavior justified itself. This was pointed out by Chatham House rules forbid me saying who it was, but somebody pointed this out. The reaction was volcanic. They were told, nope, this can't happen, except that when I've tried to find something, a standard that says this can't happen, I can't find any formal limitation justifying it. Although I'm very much in favor of this being illegal, mind you. I mean, there's no meaningful programs if this could happen. But people seem to be willing to use examples of this type in the case of memory order relaxed when concurrency is in play. All right, so that leads us to memory order relaxed. And one of the ugly things about C++ memory model is it allows out of thin air values. The canonical out of thin air has a store to X from Y, and then another thread does a store to Y from X. If they're both relaxed, then even if X and Y are initially 0, you could end up with X and Y equaling 42. The basic reason is that neither C nor C++ respect dependencies. I mean, they respect some dependencies. There's a limited set they have to respect. But in general, the standard allows them to break them. The thing is, if you have a random program with memory relaxed, it's problematic. And the problems can get quite ugly, and there's a working paper talking about that. So one reaction is just don't ever use memory order relaxed. Unfortunately, you have memory barriers, and that messes up your performance in some cases, and therefore people do use relaxed. So instead, my advice is don't randomly generate programs using memory ordered relaxed access. In fact, randomly generating programs is kind of a bad idea to start with, AI and machine learning notwithstanding. Basically, if you want to randomly generate concurrent programs using machine learning, it's your job to teach the machine learning what programs are legal, okay? And whether it's a person or a machine, you should restrict yourself to programs using known good patterns of memory ordered relaxed. And for that reason, Hans Bohm and I put the paper at the bottom here. Now, there's a lot of discussion in Matrix. I haven't quite figured out how to respond to it. So if somebody has something that I should respond to, it looks like a good discussion, mind you, but I'll let you guys have at it. Volatile load and volatile store. This is sort of a C++ answer to read once and write once, maybe. Jeff Bastian and I have been pushing on this a little bit, not much lately. People doing optimization generally hate volatile because volatile restricts their ability to optimize. And they're starting to come around to the idea that Linus pushed a long time ago, which is that if you mark the axis as volatile instead of the variables, that gives you more ability to optimize. Okay, address data dependency ordering has been a thorn in my side for almost 2 decades now. There's been a lot of electrons burned on this. This is kind of the major papers over a period of a very long time. And one version, the last version of each rather than all the versions. There's an implementation. There's been a Google Summer of Code prototype in GCC, which was partial. And the next step is to go further along this and to actually get something that works reasonably. The basic thought for the standard is that you mark the pointers that are carrying address or data dependencies, which isn't really what you want in the Linux kernel. My hope is that we can convince GCC and Clang LLVM that they should give us a command line argument that says pretend all the pointers were marked in that way so that we don't have to worry about it. Or maybe in the fullness of time, we'll decide that it's a good thing to mark the pointers. Who knows? Anyway,
can also
C11.
get
Go ahead.
So can we also get an attribute for variables to mark as being a dependency? So for non-pointers.
That sounds like a good next step. I don't think it is at all safe to. There's code in the Linux kernel I'm pretty sure is broken. They just take an integer and pretend that the compiler isn't killing them, and then load it with read once and then expect an array reference to give them ordering, which maybe it will, but good Lord, that's dangerous. There's just too many things the compiler can do to the integers. I'm sorry. So if we're going to do that, we need to mark those. That's not optional. And we should do something about that code now. It's not good. That code is
well,
unsafe.
it's mostly x86, I think, that does it, but there is something in generic timekeeping. x86 is okay if we do to TSO, but yeah.
Well, if it's x86, why not just use a load acquire? Come on, it's free, right?
Yeah. So, but the timekeeping code has this in generic code, and there a annotation might be nice.
Something, because right now that's playing with fire. Again, there are a ton of optimizations the compiler can do to integers, and you're playing with fire there. I'm sorry, yeah, that's just not safe. So yes, if we're going to have, right now I'm pushing just on pointers to get started, but once we have some way of marking them, then it'd be a good next step to apply to integers. But first, the point we're at now is we have to get implementations in GCC and LLVM, and I haven't quite figured out how to make that happen yet. But that's something on my list. If somebody has some ideas to make that happen, please don't keep it a secret. There's been a couple people that have at least talked to me about it, but I don't know that there's anything that's gone forward from it. But completely agreed. I'm not saying that carrying dependencies through integers is useless. I'm just saying it's freaking dangerous right now.
Yeah, I hear you.
So as long as somebody other than me is verifying that the code is generated all versions of all compilers and all architectures is good, I'm okay, but I'm not doing it. Anyway, I bet that it's about time for us to be done. The main thing is that one of the problems we have is the concurrency in C++, C++ communities went their own way for several decades. And the C++ and C guys did a whole pile of stuff that just was broken for concurrency. And the concurrency people have historically not worried too much about the compiler because, well, if you worried about the compiler, you didn't get your job done. And it's going to be a long, hard road bringing these two communities together. Anyway, I don't know if we have time for questions or not. Let me take a quick look at the chat and see if there's something that, there's going to be a resolution of made up undefined behavior. There are people that are deciding to take this seriously. The optimization has driven so far into undefined behavior that it's going to be a food fight. Doesn't mean we shouldn't have it, but it's going to be a food fight. We'll see how it goes.
And then there was a question I saw very early on from Wedson that said the strategy to call synchronize RCU if allocation fails for call RCU wouldn't work for scenarios like the ones you described yesterday, where you would have a nested read, lock, and update, would it?
Yeah, exactly. And what happens if you're using KV-free RCU with a single argument, which is the case where it'll go and call synchronize RCU if it has to, if memory allocation fails. You're only allowed to call those from contexts where you can sleep, and that is not in an RCU read site critical section. So in the Linux kernel, we're restricted to make it so that it works reasonably. In C++, they've got the option of restriction or not, depending on the environment. In a lot of cases, they just say, hey, memory allocation fails, bang, kill the whole application. Okay. All right, so we got 3 or 4 minutes left, if I'm not too confused. So
more like 4, yes.
4, okay.
Yeah, 4, 3.
Okay. So my timekeeping hasn't completely exploded. Let's see. See what we got here. If there's something that C23 might include auto, that should be fun. C++ code these days uses auto really, really heavily. Auto, some variable equals some whole pile of stuff. What's the type? Who knows?
Well, I mean, like we have pretty good coding standards that say like when the right-hand side of an assignment has like a static cast or a dynamic cast or something that already demonstrates the type very clearly, then it's kind of redundant to have it on the left-hand side of the assignment.
That's true.
Well.
That's true. And if the type is, and I was being a little bit facetious, but in the C++ world, if you have lambdas with captures and arguments, stuff like that, just figuring out what the type is to type it would be a total pain. So it's not like that C++ had any choice but to make auto work, right?
Yeah, iterator types are another awful thing to try to figure out and type.
Yeah, no, it's it is useful, but it's
but yeah,
interesting.
so we have a bunch of language people here, or compiler people. So is anybody working on the dependency stuff in the compilers, and what do they think about getting us this attribute?
See Marco in the chat, but we might have more information probably during Will's talk that's coming up.
That is where we're covering control dependencies for sure. I want one clarification. It can't be an attribute because attributes aren't allowed to change the semantics. In C++, it could be a funny templated class, kind of like atomic. In C, it would probably have to be a keyword, underbar carries dependency or something like that.
And this is because of funny spec, or is this? I mean, the compiler could still do it.
Well, it's just that attributes, a compiler is supposed to be able to ignore attributes and still produce a correct program.
Yeah, that's not going to happen.
That's why we can't use an attribute. We have to use a something else instead, which may be a type modifier or whatever. Seger, sorry, go ahead.
It's true in the C and C++ standards. It's not true in the GCC implementation.
Okay. So in the standard, it has to be so what we could do is we could have an attribute in the short term potentially, and then figure that if we ever browbeat the standard and doing something reasonable in this area, we'll have something else that can be switched to or used instead. Is that fair, Sager, or am I missing the point?
It's completely correct. It's fine.
Okay. Of course, some would argue that the standard will never take dependencies of any sort, and so it'll always be an attribute, but okay, whatever, right?
I mean, C++ added like must tail, right? Which is like the compiler must optimize this, and always in line. Like both of those feel like they have very explicit commands to the compiler on how optimizations need to occur or not.
That's true, but can the source code, unless it digs its own stack, which is not defined in the standard, can the source code tell that it was tail optimized or not? I think the answer is no, and if the answer is no, then it's okay for it to be an attribute because it doesn't change the semantics of the program from the standards viewpoint. You're absolutely right. You could dig through stuff and figure it out. Anyway, I bet Jose has come here to tell me that it's time to switch to Will. So thank you very much for your time and attention, and I hope this moves forward some. But let's find out about control dependencies from Will.
Okay, thank you. Okay, control dependencies. Will Deacon, right? Will be presenting this. Oh. Uh-oh. Am I still here?
Will's here. He's having trouble with audio.
Oh. Hello?
Yeah,
I had to drop off. I had to drop
Yes.
off and rejoin. Go ahead.
I got dropped off as well.
Yeah, I think the connection just reset for everyone.
Oh no. Okay, well, let's see.
It did not drop me off.
Oh, okay. So it was only a subset of people. I see. Still scary. No, the shared notes are not working for me. I cannot get /p/. Control dependencies. Okay, actually, let me make sure that the people have not been like dropped with a little poll. Still connected.
Yeah, funny that, Will.
Okay, so people please reply to the poll so we know that you are actually here. Sorry, Will,
still
for
here.
the delay. Okay, so 62% of people are replying that they are online. I guess we should go on, yeah. Okay, so the slides are set. Let me make you presenter again. Where are you? Here you are. Okay, you should be set up now. You are on mute. You are on mute. Please unmute.
Am I better now?
Yeah, perfect.
Okay, cool. Sorry.
Okay, thanks.
Quickly get this done before it all falls over again. So yeah, thank you very much. It's me again. I'm sorry. So we're going to talk about the never-ending saga of control dependencies. I spoke about dependencies last year, so we're going to focus specifically on control dependencies, and I'm going to have quite a lot of material because unfortunately there's tons of introductory stuff that I don't really feel I can skip over. So let's get on. Okay, so mega thread alert. If you've got a couple of weeks with nothing to do, you can go and read this. It's started by Peter, who is on the call, and that's the background behind this. It kind of petered out. There were lots of different solutions that came up. It kind of just stalled, and I would like to talk about it here to see if there's anything we need to do or whether we can just leave it, as it is and not do anything. But let's see if we can make any sense of it. So to recap, what is a control dependency? So when we're talking about dependencies here, we're talking about them from a memory ordering perspective. So concurrency model perspective, where you have a load and then some other access, and you want to use a dependency ordering between them to ensure that those two memory accesses are observed in order by another CPU. So for control dependency, the normal case where you get order is from a read to a write. So the result of a read is used as an input to a condition guarding a write. So if you look at these 3 lines of kernel C code at the top right, we load from foo, so we dereference this foo pointer. The read once is basically a volatile cast, and if the value is greater than 42, we do a store to bar of 1. And this arrow I've drawn in helpfully shows that there is a control dependency in this case from the read to the write. And this ensures that the write is ordered after the read, because if you let that write go out early and then X was less than 42, you'd be in big trouble because you did a write that was not supposed to happen. And then there's some assembly code that shows what that looks like for AH64. There's a compare and a conditional branch that branches over the store if it's less than equal. In practice, not all of the writes will be annotated like this write once. So later on, if you're thinking about solutions to this, you can't rely on this write once being here. In particular, if there's no data race on the store component, then that's not required. So we wouldn't necessarily have one there. So these control dependencies, they're not used super frequently because they're quite hard to reason about, and there's a lot of scope for getting them wrong. But they are used in some places in fast-pass and Linux kernel instead of things like stronger acquire memory barriers. So you might know of acquire from C11, and we have acquire in the kernel as well, but that provides more ordering, right? That's read to read plus write, and it's not point to point, it's a read to everything that's after it. So we could use an acquire. You could replace all control dependencies with acquires. You'd still be correct, but you potentially pay a performance hit from doing that kind of thing. So control dependencies can, in theory, be broken by the compiler, and they can, in theory, be broken by the CPU. So let's see what that means. So I got a nice quote from Al Capone, which was a nice control dependency you got here. It'd be a shame if anything happened to it. And that really is we're really on the edge here of the compiler's trying to break them, the hardware's trying to break them. It's a bit of magic, a bit of good luck, I think, to make sure that you get the ordering out the other end. So let's have a look at the mod boss number 1, the compiler. So you all know this better than me, but these are some of the things that have been discussed on LKML and in the memory barriers TXT and in that thread that I mentioned at the beginning. So one way that a control dependency might be broken is this top right example here, which is if the condition is optimized away because it evaluates to a constant. So if instead of checking against 42, we do a mod with max and check it against 0 and do the right ones. If you define max as 1 in some header file, then obviously the compiler can see that this is true and get rid of it, and now you don't have order anymore. Another example would be if a write occurs regardless of the condition. So that's what this second example down at the bottom is. So we load foo, check it against 42, and if it's greater than 42, we write 1 to bar and then call frob. Otherwise, we write 1 to bar and call twiddle. So you could hoist this write once above the condition, and now there's no dependency from the read to the write. Then there's also some stuff about whether the exact instructions that are used by the compiler in the backend could cause problem. More about that later. There's the potential for speculative stores. So can a compiler hoist the store up knowing that it might overwrite it with something later? I think we pass fno allow store data races when building the kernel. And I think that's supposed to defend against these kind of things or prevent these kind of things. But I don't know how much of that is good luck and how much of that is intentional. But the kind of examples I've got here, they don't, well, maybe the first one, but even then, they don't really feel like real code examples. It's hard to point to a concrete piece of code and say, look, this has gone wrong before. I don't think we have any data for that kind of thing. But if it does, it'll be pretty subtle and undebuggable. It would be nice if we could define what is real code and what's not real code, so that we could, say some examples it doesn't matter and others it does. But that's also very difficult. You end up sort of need to define syntactic perhaps versus semantic dependencies, and I don't really know how we could do that. And there are more examples like this in memorybarriers.txt if you want to go and have a look. So what about the CPU? So in theory, the CPU could. So let me rewind a minute. So the CPU implements an architecture, right? So for ARM, which is what I'm most familiar with, you have the ARM architecture, and you build a CPU to the architecture. And the architecture sort of is the set of rules which you have to obey if you're building a piece of hardware. And typically, the architecture is constructed to strike a balance, at least for memory ordering, between the needs of programming languages and the desire to optimize your microarchitecture. And they strike a balance between, okay, for example, C11 requires these orderings, but we want these hardware optimizations, and they make sure that the architecture is written in such a way that it doesn't break C, but also doesn't preclude optimizations. So control dependencies are outside the scope of C11. I didn't see Paul's previous talk, but hopefully I haven't contradicted anything. I think that's all about address dependencies. So it kind of means that if you're using control dependencies, you're in this land where maybe the architecture might change to lean more towards hardware and then catch you out. And things like value prediction. I mean, CPUs already do lots of branch prediction. If you add value prediction to the mix, you could potentially have speculative stores. You can have the same sort of thing, right, occurring regardless of condition. There's a conditional instructions and retrospective relaxations. Moving this boundary between hardware and languages, you could end up with code that used to work now no longer working. So on ARM64, thankfully, we don't have speculative stores, which is really good news. There is a sort of example of this right occurs regardless of condition. They've got this thing called pointed dependencies. Like Jad was hopefully going to be on this to talk about it, but she's got some personal things to deal with, so she couldn't make it today. So I'm talking, this is my understanding of how this works. So if you see this example again in the top right, we load foo, and then if x is greater than 42, we write 1 to bar, else we write 2 to bar. So in this case, we do have control dependency from the read to both of these writes. And in the assembly down here, actually those writes are collapsed into a single write instruction, but there is a control dependency. And then after that, we have a write to another variable, baz, of the value 3. But in the way that this has been, so the compiler could obviously hoist that up. But if you prevented it from doing so, for example, using a compiler barrier or something, the CPU, at least on ARM, could still perform this store to baz early. It could actually hoist that. So I've not drawn an arrow from the load to that last store. There is no control dependency there. And the reason is it's emitted, instead of a conditional branch, it's emitted this conditional select instruction, which is like a ternary if, and it uses that to select the value which is stored to bar, and therefore there's no conditional branch, right? The branching kind of happens, if you like, inside the C-cell instruction. So that's one example of a control dependency where you might expect it to be there, even you convince the compiler not to reorder things, but then the CPU reorders things. So it's another great quote. You've got to ask yourself one question: do I feel lucky about the compiler's instruction selection path? Because if the compiler spits out a conditional branch, you're good for order in that previous example. If it spits out a conditional select, you don't have the order. So one solution to this in that mega thread, and I think there were multiple iterations on this volatile if macro, but I think this is the one that seemed to get the most traction at the end. And Peter, please jump in if I get that wrong. I think this was it. So this was a macro called volatile if, which used instead of if when you've got a condition which is used as part of a control dependency. And I don't necessarily want to walk through this, but it has, it checks if the condition evaluated to a constant, because then we know we might have that one of those optimizations I spoke about earlier on. And it relies on lazy evaluation with this barrier here. And we know that we're going to get a conditional branch out of this. You're not going to get a conditional select instruction. You're not going to get the thing optimized away. It's not clear how robust this is, because the expression x can still be optimized. We've got this built-in constant check, but Is that sufficient? I'm not sure. It relies at least on this barrier here being opaque. I know that I think in the thread, some people pointed out that if you have multiple barriers, there's like a string comparison on the contents, which is just an empty as a volatile, but there's a string comparison on those in GCC, and they can be optimized away or combined. The one thing about this is it's not, if you wanted to upgrade control dependencies to acquire, which is what I mentioned earlier on, you can't easily do it with this because the load part, which heads the dependency, is hidden away in X. It's not made explicit, so it's not straightforward to upgrade this to acquire semantics. And there were some suggestions on the thread that we might be able to come up with it. Well, there was actually a proposal, I think, from Peter again, to disallow an else clause, which solves some of the right occurs regardless of condition cases. But there's also an unclear impact on code gen from using this. It's not clear how it interacts with compiler optimizations, for example. Peter?
Yeah, so there's a variant of this where the volatile if macro uses a volatile condition macro, and then the condition takes X, and that might be more amenable to upgrading to acquire.
Right.
But it's all a bit of a mess.
Yeah. The volatile condition, would that then be passed to the, well, I don't know, I'll ask you later rather than try to explain it audibly. Okay. Next slide. So another solution was to do nothing, and this was from Linus suggested this. He said, well, we could just define volatile if to be the same as if, and we use it as a documentation purpose, because the issues you pointed out, although I pointed out in the thread, which I've sort of summarized here, are all theoretical. We don't have any real problem that we're solving here. You know, everything's working well. This is just voodoo programming. We shouldn't do this. And you know, I can actually understand that viewpoint. But in terms of having a bit more of a long-term view, like, will they remain theoretical forever? And if suddenly we start seeing breakage, it would be nice to have a solution in our back pocket, which we could then actually try to experiment with, rather than have to, you know, come up with a solution on the fly when we've got systems that are actually failing. And then the nuclear option is to upgrade everything to acquire. I've said this is currently my preference. I think it's my preference if we have to do something, if we decide to solve the problem, because I just feel that this is the kind of the easy thing to do. Barrier instructions exist exactly for this purpose, and if we add the barrier instructions, then the compiler's not going to mess them about, and the CPU is not going to mess them about, and we know we're good. Obviously, this needs further benchmarking on recent CPUs. Some preliminary benchmarking I've seen in the past, at least for some ARM64 CPUs, for upgrading relaxed accesses to acquire, indicated that the performance was in the noise. But that's not, I think if we were going to do this change, we would certainly need a lot more benchmarking to see whether it's feasible, and it probably isn't feasible for all architectures either. So maybe it's not a good way of
Yeah, there's a whole bunch of the RISC architectures that only have sync for acquire, and then they get the heaviest barrier of all.
Yeah. Yeah, and we'd have a problem actually. The benchmarking I referred to on ARM64 only did it for read once, it didn't do it for the atomics. And we don't have RCPC acquire atomics, so we would pay a bit more of a cost there. So definitely some more numbers. This might not be, although it's definitely correct, it might not be performant. So I don't know how much time I've got, but I wanted to, another thing that came out of that thread, which I think is relevant for this audience, but is slightly tangential, is we talked about barrier. And as I mentioned earlier on, so barrier is used as a compiler barrier, and the definition of it was earlier. It's just an empty as and volatile with a memory clobber. And GCC performs string comparison on those blocks. So if it sees them barrier on either side of a conditional, it can actually merge them into one. So there was some desire on the thread, I think, for having a version which is not susceptible to that. And there were lots of various hacks. I'm not sure anyone came up with some hacks that would work. It'd probably be better to have something from the compiler, maybe a built-in or something. And while we're at it, if we're improving barrier, having barrier which allowed us to specify access types either side. So rather than just, you know, all your memory accesses before must be before and everything after needs to be reloaded. Being able to specify the 4 combinations of load to store would be desirable. Potentially would help with code gen. It'd be interesting to research that, to implement it and see what the impact is.
Right. So I recall from that thread at least discussing, I think maybe the write memory barrier, which would permit the reads to be reordered across it. And I think that's something like looking at LLVM's representation of inline assembler. We do already split up whether like we break a memory clobber into both a read and a write. So it is easy for us in LLVM and Clang to split that up. I would just like to try to standardize that with GCC developers on like, what do you want the clobber to be called? Because
absolutely. Or have it as a built-in so that we can, well, maybe that has downsides as well, but it'd be nice to avoid the first problem, right?
Well, Linus made the point that it would be helpful, I think, to have actual assembler in there. And like if you have a built-in, then it's just a barrier and you can't have these semantics on and inline assembly in the same statement.
Yeah, that's true. So then we need something else to address that first problem. But I mean, maybe just doing string comparison on as and volatile is not worth doing.
Yeah, I mean, part of me feels like the volatile there is like you didn't want it to get eliminated. I don't know. That's curious to me.
Okay, and I think that's all I had. I don't know how much time I got left. I'm sorry, I kind of lost track, but I wanted to get through that. So
we have 10 minutes left, so we should be good. I don't know if Marco is on the call. If Marco happens to recall, we did discuss this a little bit with Paul off list on trying to figure out could we provide a built-in or what we could do here. And for the life of me, I can't remember how that thread was resolved, kind of thing. But it's probably worth bringing up some of the points there if Paul or Marco happens to recall them.
I think the summary from that was, yes, it's interesting. But then we also have to consider what the major architectures want. And I think this also the decision if this is worth doing depended on what is, say, ARM64's preference. And I think that's what Will mentioned, right? The preference to upgrade to acquire. And if we end up with only a few architectures that need this, then it's not worth doing.
So I guess that's a separate question, though. We have two things. We have control dependencies, which is what Will's talking about now, and then there's address data dependencies, which are more in the RC reference thing. Is that your feeling for them? Is that they should upgrade for acquire for ARM v8, or is that Will I'm talking to, or where are you at on that?
So
I guess we should ask the RISC-V guys too.
Yeah. So I for address dependencies and data dependencies, I'm quite comfortable with the CPU side of things. But I'm still don't get that warm fuzzy feeling that from the compiler can't break them, right? Which is what my talk was about last year. So currently in mainline, if you enable LTO, we do upgrade read once to acquire, just to make sure.
So if we had a compiler solution for address and data dependencies, as opposed to control dependencies, that would be something you'd be interested in and would be potentially supportive of, depending on everything, of course. Obviously, assuming it actually pushes to LTO and is a complete solution instead of somebody halfway doing it, tapering on the top.
Yeah. So for data and address, I would be more than happy with the compiler solution because I think the hardware's in the right place there. But the hardware is really pushing the boundaries on control dependencies, and I'm worried about it.
Okay, so does that seem reasonable, Marco, as a way forward, or is there something about address and data dependencies that's harder in the compilers you work with?
I think we didn't. I mean, for data and address dependencies, I think that wasn't exactly discussed. We discussed the control dependencies, and for that we said, okay, if in the architecture we decide to upgrade to acquirers, then doing this in the compiler may not be worth it, and we end up with something in the compiler that's not even going to be used.
Yeah, no, I agree with you completely on that.
We didn't much discuss data and address dependencies. I want to mention that I got some folks from a university interested in this, and they're working on a compiler pass to essentially check if certain dependencies were broken or not. I'm not sure how far they've gotten so far. I don't want to make any promises, of course, but I think one thing that I've been wanting for a while is a way to essentially measure what is actually broken. And I hope that their work will provide something like that. And I think they do want to provide this for both the address dependencies and control dependencies. But so far, I haven't seen any results yet, unfortunately.
That'd be really cool. I mean, yeah, I understand that it's uncertain as always, but that sounds like an excellent piece of information for us.
Yeah, I think with any luck, you'd end up either you get lucky and it says actually we're not breaking this, and that's good news, or you get a whole load of new examples which might be somewhat more realistic than the ones I had in here. So that would be fantastic.
If you want control dependencies defined in the compiler, then you need to define what a control dependency is, describe its effects, not on the machine code, but on the actual semantics of the program. Because you cannot say what the machine code is supposed to be like. The only way, well, you can write assembler code, but that's the only way.
Yeah, agreed, and that's much more difficult, in my opinion, for control dependencies than it is for address and data dependencies.
Yes, very much so. Yes.
Although I freely confess that my first attempt to define it for address and data dependencies in the standard was not a success. I'm sorry.
Yeah.
I mean, on the flip side, so I understand what you're saying. On the flip side, like a macro to force a conditional branch instruction, I know that's not defined in any language terms whatsoever, but having that as a built-in does allow a significantly better implementation than us having to.
Yeah, the macro does not force a conditional branch instruction. That's just what you see happening on all your test codes on all architectures you try to do. It doesn't actually force conditional branch. So if conditional branch is what you actually depend on, then you really need some way to really generate a conditional branch.
Could we go to the slide that we're talking about just to make sure, because I'm not sure I'm putting it with the right thing with the right thing here.
Yeah, here we are, this guy.
So is that the right one, Sager?
The correct example, you mean? Sure.
Yes. Is that the correct example?
Well, yes, it's one example. That's not that does not force a conditional branch. Yeah.
Right. I guess the question is it possible to rewrite a macro like this using inline ASM that explicitly has a C cell instruction? Or sorry, is the point to avoid the C cells?
We don't want the C cells for this. We want a conditional branch, and to be honest with you, I don't see how this could be compiled in any other way. But I agree that that's not enforced by construction.
Well, there could be other code around it, right? That helps optimize things. So part of the condition goes away and all that kind of stuff.
Sager, suppose that the condition was based on a volatile load. In that case, we know the load can't go away. So to avoid the branch, or well, I'm going to ignore C-cell for a little bit. That's obviously important, but I'm going to take one step at a time. If we have the volatile load, it seems like that should prevent combining with previous conditions, or is there some trick I'm missing here? I'm sure there's some trick I'm missing, but let me know what it is.
Well, if you have a volatile load and the if is actually based on results of the load, right? Then that cannot be optimized away, I guess, right?
Okay, so if we make sure the condition depends on a volatile load, then this would make a branch, or am I being optimistic in my interpretation of what you said?
Well, it would generate some code that has the same effect as a conditional branch.
So it might, for example, generate a C-cell instead if it could.
Exactly, it could still be a C-cell.
And I think from what I saw on Will's slide, is a C-cell, well, at that point we get into having to look at what else was going on. But I think Will said that C-cell itself respected the control dependency.
That's correct. Yeah.
And then turned it. Yeah. Okay.
I'm not sure what that means. C-cell respects the control dependency.
So it means if the value being stored is the output of a C-cell instruction, and the condition of that C-cell instruction is determined on the result of a load, then the load to the store are ordered.
Okay, sure.
How many minutes was that, Jose? Was that 1? Oh, it doesn't matter. I think it was 1.
Yes.
Okay,
Yes.
gotcha. All right. Okay. So it sounds like there's not much of an appetite to say that this works, but there's also not much of an appetite to support this in the toolchain either. So I'm not really sure where it leaves us. I suppose.
Right behind the 8 ball, as always.
Sorry, Paul?
Right behind the 8 ball, as always.
Yes. I suppose for now we'll do nothing then. But I don't know. I have a nasty feeling this will come back and bite us in the ass as it is at some point. So maybe I'll be back next year with some more dependency talks.
So maybe I'll have to dig into the thread eventually, but we discussed ASM go-to on the chat. So I mean, that would be a proper way to force instruction selection to choose an actual conditional branch. But I'm not aware of what Linus don't like about this kind of way of doing things.
So I think that was actually the initial implementation that Peter posted in that big thread. So actually, if you do click the link for the big thread, the first thing you see should be exactly what you described.
Yeah,
refined based on discussion.
Linus had an opinion.
Okay, there we go. Probably about email 995 or something in the thread. But I tried to find out where it had concluded for this slide deck, so I didn't just waste people's time on something that was discounted. Cool. Well, I better stop. Thanks again, and I'm not sure who's next, but I'll get rid of myself. Thanks.
Now we have a break of 15 minutes. Actually, I have a question because, okay, we have the notes that Nick is taking in the shares notes, but is anyone gonna actually make sure that all the discussions and proposals for new built-ins, new attributes, and so on in the toolchains are gonna actually be submitted and discussed upstream, like in the GCC list and also in the LLVM list? Maybe the toolchains mailing list in the kernel is the right place for doing that. I don't know.
Yeah, I think that's a good start.
So we can maybe send the notes, the shared notes there. I just subscribed, by the way.
Yeah, sure.
Okay.
Yeah, pretty much we want to make sure that before either of us sign off completely for the day, that we copy and paste the notes so we don't lose them.
Oh yeah, and please, nobody should click on the end meeting.
So we subscribe to this list by going to kernel.org and looking for tool chains or something? Could
someone pasted the link.
Yeah, let me find it. I have it in the notes. I just got to scroll down and find it, and I'll put it in the chat again real quick.
Yeah.
Thank you. Peter got it here. Thank you very much.
Max, if you're around, do you want to do a quick camera and mic check? And we probably can set up the slides because I don't think that we have them quite yet. Is that right?
Yes,
Jose?
we have them. Yeah, I uploaded them like in the previous break. Yeah.
Oh, okay, okay.
Let me. Okay. Oh, here it is. Yeah.
All right. Can you hear me and see me?
Yep.
Yes, but there is 1 more minute of break, and not everyone. Only 18% of the people came back from the break.
Mm-hmm. Great. And how do I control the slides?
Oh yeah, sorry. Let me make you presenter. Here you are. Okay. Now you must have superpowers.
Awesome. Thank you.
All right. So it's time. Thank you.
Okay. Well, hello everyone. My name is Maxim Panchenko. I work at Facebook, and today I would like to talk about optimizing Linux kernel with Bolt. And Bolt is a binary optimizer that we developed at Facebook. So it's an open source project. We're also trying to include it in LLVM monorepo, since it's using the LLVM libraries, and it can facilitate building more tools on top of LLVM. Please interrupt me anytime during the presentation, because it's more, I want it to be more of a discussion than a presentation. And the proper name for these slides should be more about challenges of optimizing Linux kernel with Bolt, because as of right now, we are not optimizing Linux kernel or with Bolt, and I'll explain why. I don't have all the answers right now. I don't even think I have all the proper questions to make Linux kernel fully optimized with Bolt. But let's start with the slides, and I'd like to briefly describe what Bolt is, how it works, which will be relevant to why we have challenges with the Linux kernel. Bolt stands for Binary Optimization and Layout Tool. It works on precompiled binaries. It's takes binary as an input and also applies a profile to it. It constructs control flow graph internally, and reorders code, which is its main optimization. But the set of optimization is not limited to just code reordering. Why we want to do it? It's because it brings us a lot of performance wins on top of PGO and LTO for large applications. Large applications mainly means something that suffers from a lot of CPU front-end stalls, iCache misses, ITLB misses, and branch miss predictions. From the very, very high level perspective, Bolt does a code defragmentation. So if you look at some binary image in memory mapped to the space, typically the code will be laid out in the order that was written by developers, which is far from optimal from execution perspective. Then with optimizations applied, with compile optimizations at link time, and perhaps with a linker script, we can get a much better layout. But to achieve the best one, we actually have to use post-link optimizers such as Bolt. Defragmentation is not the main optimization. The actual code layout is driven by an algorithm developed also at Facebook, which improves the application performance slightly more on top of like very
coarse grain defragmentation. The results, I'll show you some results. This actually achieved on compilers themselves. So it turned out that compilers such as Clang and GCC, they suffer from a lot of problems I described in CPU frontend. So the performance of the compilers can be improved drastically with Bolt. And here you can see some numbers gathered on, well, it's not the latest CPUs, but you can see that Bolt can speed up the compiler, for example, building some project by almost 30%. The same can be achieved with PGO and LTO optimizations, or almost the same, but to get the maximum benefit, it's actually best to apply both optimizations. Well, actually, PGO, LTO, and Bolt. This is how you get the maximum acceleration of the application. Bolt currently runs on x86, and some support is added for ARC64. We target ELF binaries, but also there's a very draft support for macro binaries. To use, you don't have to rebuild your application, although we recommend relinking it with a special flag that will add metadata to the binary. It's a -- me3 logs flag. The code will be exactly the same, it just adds some information into the binary that makes it easier to optimize and change layout and relocate code. When you get a profile, you can use Linux perf tool or any other sampling-based tool that can be converted to Bolt. The output should be converted to Bolt internal format, and we prefer to use LBRs, last branch records, on Intel CPUs. It gives us the history of execution, like a tracelet of what happened without any overhead. So we can do profiling in production and take a binary from production and optimize it and make it faster. Yeah, LBRs, I think the AMD has some support for it. I know some ARM vendors also has similar features. So it's not super rare, but if, for example, you're running your application in the cloud, you don't have access to LBR. For these scenarios, we provide instrumentation. You can actually use Bolt to instrument the binary, run it with a slowdown, of course. That's the downside. But then you get the profile and you can optimize your binary. The question is, like, can you do the same sort of optimization in the compiler? And it's not as simple to answer. With a single profile pass, you generally cannot. With two profile passes, I guess it's possible. It's more cumbersome solution, but I think it's possible. And so if I'm not mistaken, features like that were implemented in LVM, but they're not. I'm not sure how many people use those. Also, with Bolt, you have exposure to more code that just coming from the compiler. It could be third-party libraries. It could be assembly code. So you have ability to reorder any code on the input. Internally, that's a slide that describes how, on the high level, Bolt works internally. It looks in the binary. It discovers functions in it, because that's the highest. Well, we consider that the program consists of functions, and that's a pretty valid assumption. I mean, it doesn't have to, but typically that's what the regular application will be looking like. And on the ELF, function boundaries, they are well defined, and they are part of x86 64 or MB64 specification. if you look at each frame, they will give you the boundaries for the entries. And one of the optimizations that we do, for example, we break function boundaries. We split functions into pieces. So for that reason, we have to update each frame sections, as well as some other metadata I'll talk later. Once we discover functions, we disassemble code, we reconstruct CFG. You know that in general case, it's not possible. It's a halted program. When we talked about OBJ2, we mentioned that sometimes code from the compiler for jump tables, it breaks the assumptions. So this can happen. And it's important to realize that for optimizing the code, we don't need to know 100% of all control flow graphs in all functions. So if we decide that CFG is not buildable for some function, we can actually skip optimization of it. And that's the kind of luxury that we have when we optimize code, as opposed to OBJ2. So OBJ2 has to be like 100% correct, right? But for us, we can decide that we can give up on some functions, and we only, let's say, optimize 98, 99% of all functions. But for performance perspective, it's not as important. Like if you don't optimize 1 or 2% of functions, you still achieve most of the performance benefits. Is it a decompiler? I think decompiler is supposed to raise the code from binary level to a much higher internal representation, or maybe even source code, which Bolt right now is not doing because it doesn't have to. It only does code layout optimization. So our internal presentation is kind of very simple. It's built on top of an MC layer in LLVM, but it extends it. It builds functions, it builds basic blocks, but all with MC instructions. So that's how it operates. And of course, it applies profile, it reads debug information, but we only use debug information to update it. We don't rely on debug information for any optimization decisions or even control flow graph building decisions, because WRF is not meant to provide like to be 100% correct. And I think when OBJ2 was written and ORC was introduced, people had this very, very similar concerns. I'm trying to read comments on the chat, but also feel free to speak. Yeah, well-grind internally, I think, yeah, it's very similar. But again, for well-grind, it's they have to fall back to interpretation when they don't understand some code. We don't have to do this. We can just, like some function with a very vague control flow, we can just skip over it. And if for example, could you use Bolt to build tools similar to well-grind to do instrumentation? I think you can. Like for example, to build a memory sanitizer or to assist memory sanitizer, that's also possible. Because right now, say sanitize, the exposure they have is only to the compiler-generated code. Assembly code is left uncovered, and this is where Bolt can help. So it can introduce instrumentation to assembly written code to assist sanitizers. Well, after we do our optimizations, after we reload the basic blocks, that's one of the main optimizations in our tool. We emit the code using MC layer, and we rewrite the binary. We can do it in place, meaning this is something that I'm actually considering, at least to begin with, in Linux kernel. When we don't move functions, we only build the basic blocks within existing function boundaries. Of course, it has some limitations, including performance limitations, but it's the easiest way to start optimizing the binary. Of course, the full optimizations involved complete reshuffling of the code, the one that I showed on the heat maps. But it's a lot more difficult to achieve, especially for the binary with a lot of metadata that needs to be updated. Okay. So which brings me to the topic of actually challenges, rewriting and optimizing the Linux kernel. Of course, the focus here is on optimization, but maybe the scope shouldn't be limited to just optimization. And if you have any ideas related to instrumenting Linux code or adding some security mechanisms, that's definitely something we can think of adding to Bolt. For one thing, Bolt is able to introduce red links into the code. For example, for fault binaries that were not hardened, we were able to inject red link code in them.
So some questions from the chat here. So another Nick in the chat is asking, I wonder what the optimization passes are. Your audio was a little blurred. Can you cover what you meant by movement? Something about basic blocks, perhaps movement of basic blocks?
Oh, okay. I hope, yeah, let me move closer to the microphone so you can hear me better. Right, so the main optimization is the code layout. We start with moving functions, moving basic blocks within functions. And it's driven by the profile. So you can imagine that the most executed basic blocks are grouped together. That's the very simplistic view, but that's how it goes. And blocks that are never executed, called basic blocks, they move to the end of the function. But then we can also split the function, take all called basic blocks and move them into a separate block of code that we move far away into what we call called text. And of course, then we reshuffle the hot parts of the functions. We group them together. And there's another algorithm that we use for that called hrefsort. I hope this clarifies what I mean by basic block optimizations. And I hope my audio was better this time.
So I guess the main question that I have, or the concern that I think is probably difficult for using Bolt on the kernel is that, like, while the kernel image is packaged in an ELF an ELF executable file container, we do use a bunch of non-standard or custom sections that have semantic meaning, like just for the kernel. For instance, like there's a whole bunch that you probably would never really see in user space, and a lot of them have. Yeah, exactly. Oh, perfect. Yep. Okay, so like xtable or fixup, I think were kind of the two that I was most curious about, where if I remember correctly, and someone correct me on the kernel side if I'm wrong here, is whenever we're given a pointer from user space, there's an ambiguity where user space could be either giving us an invalid pointer or a pointer referencing memory that's not paged in yet. And so dereferencing that pointer can cause an exception. And we can either try to recover from that when it's a valid pointer by paging in memory and then returning control flow back to where we came from. And we use asm goto for that in the kernel, where the inline asm actually will end in a label, where the label will now point to the next statement in C code. And I believe because of ASLR, we have to build the kernel as position independent code. And I think we may leave behind a relocation in one of those tables. I could be wrong, but I think that's something where if you're shuffling around the actual instructions in a function and that table gets out of sync where with the new location of the instruction that could fault, then we're not going to be able to recover from an exception. And that's like an immediate kind of panic kind of thing in the kernel. Like I'd expect that to prevent us from being able to boot very, very quickly kind of thing.
Yeah, I think yeah, you're completely right. There are so many extensions, I would say, to that affect control flow and control flow metadata that kernel uses, that it's kind of I think we know some of them, and I provided like a very incomplete list here, but there's a lot more. There's unwinding information for exceptions, that there are bug tables that we need to update. I would say for C++ code, right, for user level C++ code, we already update HFrame, we update C++ exception tables, we update dwarf, but that's for user space. For kernel space, it's a lot more sections, and I think it's possible that in the future there will be even more, right? I think there are, well, they are not in the future. There are right now. There are some SMP locations, so definitely something we have to be very careful, especially considering that one of the optimizations we do, we remove knobs from the code, and of course knobs are used typically just the space reservations in the kernel, right? And the kernel patches itself like at the boot time, and it also at runtime. So it's a lot of metadata to take care of. So how are we going to do this? I think the current approach, well, we will start with a very gradual. We'll take a gradual approach by looking at the functions that are easier to optimize, the functions that maybe don't have all these tables, and see where it takes us. But over time, we definitely would like to add more and more features, and finally, we'll be able to rewrite, let's say, 90% of the code in kernel, which we'll be super happy about. And I think
right, I suspect at the very least, Bolt will either need like a kernel mode or special rules and handling for certain things you probably will never see in user space applications.
Yeah, I mean, you're going to have to do the org tables and probably the ftrace tables. Otherwise, there isn't a single byte of kernel code that you can move around.
Exactly. Yeah. I think org tables are the must. Some features I think we can, I don't know if it's possible to disable ftrace just for performance evaluation, but that's also another approach. I can disable features just to get performance numbers and see if it's worth like.
Yeah, ftrace is optional. Some things like static call I don't think is optional anymore in x86.
No, static call, the jump table sites, the alternatives, all that stuff is non-optional. The paravert stuff.
Yeah, well, paravert stuff, I think it's important, definitely for some scenarios, but we'll start, let's say, without supporting paravirtualization, and over time, I think that this could be added. But these are, yeah, things that these are really good points.
Some other questions.
Someone asked,
oh, sorry,
yeah, I think there are a lot of questions. I'll try to catch up. The latest one was is debugging for altered? Yeah, we rewrite dwarf. That's our debug information format. We currently support dwarf version 4, and we add in support for v5. We also support split dwarf. Ftrace, well, at some point, yeah, that's the plan. We'll have to understand the metadata. Ftrace data is encoded and updated.
And then there was an earlier question about can you speak to some of the differences that Bolt does above and beyond PGO? It feels like there maybe some of these can be implemented in terms of PGO, or what's the major, like some of the things that Bolt can do on top of PGO?
Yeah, I think I'll cover it in one of the earliest slides. If you look at the performance numbers, we definitely improve on top of PGO. So that's the reason we want to do it, in addition to PGO and LTO.
But could you have fixed PGO?
Yeah,
can we fix PGO? It's interesting. So with PGO, you collect information at a very high level, and then you do optimizations, including inlining. And you have code after inlining, and very often you don't have the context. You don't understand how the function after being inlined behaves in this context. What can help is the context-sensitive profiling, which is being currently added into LLVM. And this definitely helps, but there's still the concern about the quality of profile. It's still not as perfect for code layout purposes. So there's always more performance to be gained on top of that. There is another question about Sun Studio compiler did this too, and this is from Diane Meyerowitz. Well, hi Diane. I actually used to work at Sun from 2000 to 2007, where I worked on the post-linked optimizer, which was a feature of the Sun Studio compilers, but I'm not sure how it was used outside of the company. It's I think it was used to optimize the Oracle database. Yeah, this like static call sites, jump label sites, fix up alternatives. Yeah, all these actions, it's all metadata that we have at least detect, at least recognize if the function is covered by some of this metadata, and if it is, we can. If it's minority functions, we can skip them. If not, we'll have to. Eventually, the plan is to actually update all of this metadata.
I feel like the best reference is pretty outdated at this point, but LWN did have an article covering what a bunch of the non-standard sections were that are in use by the kernel. Unfortunately, I think it both needs a refresh because I do think it's quite out of date at this point, and it probably needs to go in the kernel tree under documentation and actively be maintained, kind of thing. Because anyone looking at the output of readelf-S is going to be like, what is going on here? What is all this kind of thing?
Yeah. Oh, totally. Bolt is the only thing that I know which uses DW from indirect. This is for updating Dwarf. We use sometimes well, they are part of the standard, but probably no Dwarf producer uses its features. This allows us to quickly update Dwarf without having to rewrite whole sections. Another challenge is actually to once we produce new code, once we produce new metadata, like where do we place it? For regular ELF binaries, we can introduce the new segment or even segments, and it's not a problem for the code we worked with so far. Not so simple with the Linux kernel. I don't know if it's even possible to add new segments, how the loader will react to it. And one of the ideas is we actually pre-allocate some of the space during link time. So in the linker script, we can introduce new sections and use them during.
Right. If you don't use an existing section. If you don't use an existing section, then the loader may not map whatever code or data into memory. So this is like a really common issue we hit with orphan section placement in the linkers. Is like if it's not specified via linker script, it tends not to get mapped into memory, and then code and data mysteriously goes unmapped at runtime.
The kernel will just take anything that's in load and put it in memory. So if it doesn't end up in a load segment, it'll ignore it.
Okay, yeah, I think we can definitely extend or add new segments, but I think another concern is what symbols do we have to update? The kernel symbols, for example, kernel will have to do a heap allocation, right? And it has to know to do it after the last allocated segment. So yeah, that's extra information that we'll have to update there.
question from the chat. Does bolt inlining maintain symbol interposition in user code? Would this be an issue for loadable modules or BPF? At least for the kernel, I don't think we're using symbol interposition, but probably a user space centric kind of question.
Well, we support inlining, but it's not something we regularly do. We rely mostly on the compiler to do inlining, because the main benefit of inlining optimization is actually that it provides more context for the whole compiler optimization pipeline. So if you do like really late inlining, it's mostly beneficial for small functions where the major benefit is from eliminating the call overhead. So that's the only kind of inlining bolt really is meant to do. And originally, I don't plan to enable inlining, and I'm not sure what is meant by symbol interposition in the user code.
It's like LD preload.
Okay, for LD, yeah, I was wondering if it's a LD preload. Of course, we will break this if you do inlining for functions that you want to interpose on. Like it's not going to work, but yeah, you don't have to. If you plan to use interposition, like don't use inlining in bold.
And then maybe in the last minute, is there any issue you foresee for BPF or loadable modules? I don't think loadable modules can do interposition, but I might be wrong there.
Yeah, I honestly don't know, if that would be a problem, but okay, the answer is that it cannot be done.
I mean, again, I wasn't asking about interposition. Does the bolt transformations create any issues for BPF? The way that it's changing symbols, moving them around, does this have any impact?
Well, that's the kind of questions I don't have an answer to, and I would like to know, like, will it be if we properly update the symbol table, will it be a problem? We will have to look into it. Yeah.
All right. So time is up. Thank you, Maxim.
Oh, thank you. I think it was a lot of useful information there for me.
Thanks. All right. So the next session, which is the last one, is the Toolchain stuff for kernel security, which is the presenters are going to be Keith Cook and King. So let me. Hi, Keith.
Hello.
Here it is, the slides, and I guess are you starting or King is starting? I guess you are starting, right?
Yeah, I'm starting, but I assume.
Yeah, let me give you presenter. Now you are the presenter.
Presenter power. Okay. Yeah.
So let me know when King should step in, and then I will switch the presenter to her.
Okay.
Thanks.
It's close at the end. All right. Should I go ahead? Hi. This is sort of now my standing talk comparing the compiler features that we're interested in for kernel security, comparing what we've got between GCC and Clang. There are a lot of links in these slides just for reference and other stuff. So if you want to grab that URL or download them from the Plumbers site, now is a good time.
Do you have it handy to put it in the chat real quick?
Oh, sure. Yeah. I should be able to type it. Types faster than me. Okay. That should be it. Thanks. Anyway, I'll just go ahead. So I'm going to skip a bunch of the common features or things that are user space specific that we don't want to really go over and just dive right into the things we do care about. Sort of a comparison between last year and this year. So these were the things I talked about last year and what was missing. And different for this year is mostly on the zeroing call used registers, the stack variable auto initialization, and the stack protector guard location pieces. And then this year, I care a lot more about array bounds checking, and I have a new ridiculous idea that I'll talk about near the end. But anyway, I'll just go over each of these, and please jump in, like just talk over me or pop up on the screen or try to chat and I'll try to pay attention to it. So stack protector guard location. This is mostly about having per thread stack canaries. x86 for a long time was sort of cheating and using its thread local storage stuff that was really specific to x86. And we've slowly added a bunch of different architecture support for this with stack protector guard equals and then some specific details about individual registers that we want to do. And x86 actually grew this as well, and the IA32 switched to it recently. So if you try to build IA32, you don't get a stack canary on like less than GCC 8 on an IA32 build. But anyway, getting this across for all the architectures that we want to be having canary for would be nice. So right now, GCC doesn't have this for ARM32, and neither does Clang. Clang needs it for RISC-V also. So I mean, i386 people still build, but hopefully they're building on modern GCC or they're using very old kernels. Anyway, there are some associated issues with this, like leaving the canary value in the registers or spilling it to the stack. I'm trying to track those at that issue. But ultimately, I just would like to get the support across all the architectures first. Zeroing call use registers. King did this for GCC, so we've got that now. There are a couple open issues. I think she'll talk about that at the end here. Clang needs this. There have been some attempts. I think I know of one person who's still working on it, but I guess there's some infrastructure in Clang that's kind of missing to make this, makes it not so easy. The kernel supports this since 5.15, and it's kind of an easy win on performance and image size, except on ARM64, which has to sort of blindly clear 2 registers at every function return. So while it's perfectly fast, it does make the image like 5% larger, which is significant. But this is nice for, this got talked about earlier in the week, but it's good for blocking a lot of gadgets that end up in the kernel that are usable, and it doesn't get rid of everything, but it gets rid of the bulk of really nasty stuff that's easy to use. And it has, yeah, go on.
So, Case, so you just mentioned the ARCH64. Also, the kernel on ARCH64 also uses this feature already?
For call use registers?
Yeah.
Yeah, it's any architecture that that supports the GCC option, it'll be enabled for.
Yeah, I just want to make sure you, for the kernel, I remember you there's a discussing on the ARCH64, there are some performance issue with using this feature. So based on, even on that performance issue, this feature is still used in the ARCH64 for kernel?
So it's available, is what it is. So if you go look at the configuration help on the kernel, it talks about, check your workload like any other of these sort of instrumentation features. Look at the resulting image size, look at all of those pieces. Steal the presenter. Oh, sure. Is there a way that I can mark this for download, Steve?
I already did it for you.
Okay, thanks. Anyway, so yeah, it's basically people can investigate this for themselves. My goal is basically make things available, and then distros and other end users sort of figure out if they wanna do it or not. Let's see. So stack variable auto initialization. This King also did this for GCC. Clang has had it for a little bit. And this is, I think, probably one of the more important features we've had, because this will just get rid of the vast majority of the uninitialized variable on stack problems that we've had for, decades. And it won't disrupt the W uninitialized coverage either. This is already enabled by default in Android and Chrome OS. Even though like Windows uses this for their kernel in VCC. Sorry, VC++. So getting this in GCC is great. I'm really, really excited to have this for the future. Most of the, Steve's asking, are there any measurable slowdown? For most of the workloads, there's basically no measurable difference. There are some sort of extreme situations where you can notice it, and there are in fact some situations where it actually speeds things up because it's sort of it primes the cache for that area, which was a surprise to me, but anyway. So again, people should check workloads, but overall it is a net win. Yeah, I agree they should be on by default, but we'll get there. First availability, then people play with it, then people ask, why isn't this on by default? and we can get there. The timing on that tends to be at a 1 year per. So we make it available in the kernel, and about a year later, all the distros have it on by default. And about a year later, someone notices that all the distros have it on by default, and we flip the default in the kernel. That's sort of the way things that are net wins have tended to go for us. Let's see. Okay, so now sort of an expanded topic from, I didn't really cover it much from last year, is array bounds checking. This is really getting into places where the compiler knows the size of an array. It's known at build time, and you can just insert checks for it. So for years now, we've been slowly converting all the legacy 0 and 1 element arrays into proper flexible arrays. The stuff that sits at the end of the structure for saying, here, I've got a whole series of bytes. And there's a bunch of different goals here. We want to keep the 0 element arrays out of the kernel because we don't want them to come back. Warn about overlapping weird uses of these things. And fundamentally, the end goal is to never access beyond an array size. If we know it at compile time, it's ridiculous that we would ever construct a situation where at runtime we can go beyond it, or at compile time, if we can see already that it's going to overflow, that we allow it to overflow. And I'll go through each of these really quickly. So the 0 element arrays, looks like this. We change it into a proper flexible array. And we have some options as far as keeping these from being reintroduced in the kernel. Clang has the -w0 length array, which is mostly about using one of them. And I'd like to see this in GCC as well. We have this problem with the user API where we have to leave these old style things in place because of old code that's trying to build against it. So we can't just say that the kernel can't have them defined in any structures, but if we can eliminate the use of any 0-sized arrays in the kernel, detect that at build time, then we can effectively keep it out. From the chat, rewrite the old code. Well, I mean, this is about user space old code. The user API are the headers that we export to user space. So, getting everyone to change their code everywhere. Yeah, that's the problem, is there's APIs that are built this way. Anyway, getting this, I don't think should be too difficult. It's basically if you encounter a zero-sized array use, freak out. We also have sort of deal with strange cases where there's overlapping use of overlap of other members. I don't know, we get into weird places where I'm trying to give an example here. GCC has -w zero length bounds, which will warn about these kind of overlaps. It would be nice if Clang gained that as well. It's not super critical because we at least have, as long as we have coverage for these kind of static checks in at least one compiler, we generally will get the benefit for any build because it'll get changed in the kernel. So let's see. We don't want to overflow our bounds. Now, normally, if we have a statically sized array bounds, we can catch those at compile time for the most part, or instrument it so that we can check a dynamic offset. But our problem is with the actual flexible arrays. There have been some proposals to update the C language spec to include a dynamic size, like to show what member is tracking the size of a given flexible array. So in this example, you know, count is the one tracking how many elements are present. That would be nice. I'm hoping we might be able to do this, something close to this in the kernel with terrible macros.
Does it
So anyway,
have to be a local or member?
So I'm looking for the general case, right? The bulk of uses in the kernel of flexible arrays, certainly not all. The common idiom is that you have some struct that uses a flexible array and tracks the size of it through another member. There's a lot of different styles of this, but it basically boils down to that fundamental situation. I'm not saying we should change the C-spec to require this. I would like to be able to specify it, because then you get...
I'm thinking of number CPUs. We have a lot of this stuff that is also depends on number CPUs,
Right.
one way or another.
Right.
Which is a global variable and not a member.
Exactly. So I mean, that's an outlier, but and I think that the crazy macros I've got in mind for the kernel might be able to deal with a global. But as far as the general language and the places, you know, scattered throughout Wi-Fi drivers and all these places that do a ton of, I guess it's serialization and deserialization. They're taking some byte stream and shoving it into some series of structures. Usually, you know, it's a flexible array of structures that they've just deserialized out of some byte stream. So they do attempt to track those lengths. They are in most places. So a lot of places in the kernel can be, you can see this idiom repeated over and over and over.
What about the allocation of whatever uses it? Is there a way to attach the allocate? Because, you know, a lot of times you have a variable array like this. When you allocate it, you allocate the actual size, and then you say, okay, I know we have macros to help do those allocations to calculate the size. But is there a way maybe we could attach something that will then do a check that say, oh, here's the size I get it, and then...
Absolutely. That's what I've got like in the pipeline. I've got some helpers written that'll do most of this work, because it's always the same set of things that the kernel does. Like in any of these places, it's figure out how many elements I have, figure out their size, how big do I need that, plus the structure in front of it, allocate that. Now copy from over here into there, but bounds check, you know, perform a loop in that amount to do all these things. So there's like these constant, this repetition of the same idiom over and over and over, and check for overflows and check for type overflows. Like instead of, if that weren't size t count, if that were U8 count, you know, some places in the kernel don't validate that they're about to pull in, you know, fewer than can be stored in a byte. So having a common helper for all of this will be nice, or having it as part of the C language spec, because then the compiler can do those checking can do that checking. And the runtime instrumentation now knows where to go find the answer. It can say, oh, I need to go check count to see how big this is. Reading chat here. Yep. No null terminated strings. I mean, yeah, there's a lot of other situations, but the one I'm trying to focus on right now is the known sized arrays and the sort of common idiom flexible arrays where there's a instruct counter.
Do we have a helper function for allocating? I know we have struct size that's usually added to the length when you do the allocation. Maybe we should have a specific, allocating function that we could then add whatever you want annotation to that says, struct allocate, you pass the structure and then how many elements. And that's actually an allocation, something I'll allocate and not, the flags.
Yeah, that's basically what I've got built now, but it depends on the bunch of the array work and overflow work that did not get pulled this merge window. So I'm delayed by 2 months, but I'm still writing it. I expect to send it out soon. I just have to nail down a couple more pieces and get some more examples. There's a lot of weird corner cases where the count is in another structure that is a parent of that structure. So there's like weird substructure situations, but getting it captured is not my concern. It's mostly sort of getting the compiler to understand this. Anyway, so the pieces at the bottom of the slide are -w array bounds will let us do compile time checks. It's very straightforward. If we have some array that has a specific size and we use a constant expression to index it, the compiler will yell about it. We're very, very close to having -w array bounds work. Steve asked about an attribute for the element. Yeah, that's another for the size member or whatever. Yeah, that's another thought I've had, something like that. I'd like to do something. I haven't been able to construct a macro that would be able to describe it though. So it's sort of right now, every call site, you have to repeat the same information. I'd like some way to get at an attribute, but anyway, we'll get to that later. So if an index is only known at runtime, we can perform the runtime checking with -f sanitize equals bounds. And I'll move on. So again, at compile time, we've got -w array bounds. There are some problems. So Clang pretends that 0 and 1 element arrays are flexible arrays and doesn't enforce checks on those members, which is a problem. We have no way to actually do that. So this means we can't find any of the last of these. It might be hiding in corners of the kernel. It should be easy to find them, but we keep tripping over them. And GCC pretends that dereferences to 0 and 1 element arrays are flexible arrays and does not enforce checks. And built-in object size in GCC thinks all trailing arrays are flexible arrays, which completely breaks fortify source depending on if you happen to have something at the end of your structure that is an array. Even if it's not a flexible array, you just have an array and it happens to be the last member, built-in object size can't see it. That's pretty terrible. So I think it's important that we get both compilers to have a stop doing legacy flexible array handling. I don't know if that's, I suspect it's part of dash pedantic, but we can't turn that on. But we need something that we can turn this on and say, treat only flexible arrays as flexible arrays. And then I think these bugs will go away. So now we've got array bounds checking at runtime. We've got both GCC and Clang have the F sanitize bounds. They have similar problems with the 0 and 1 element arrays. GCC can disable this on the runtime, but not the compile time. And Clang needs something like this as well. It would be nice, again, if it was just the single option that fixed this for compile time and runtime that did the same thing. It just removed all the little workarounds that existed for fake flexible arrays. And for these kinds of sanitizers, it's still nice to have some way to control how we freak out about runtime failures. Right now, our options are to warn, which doesn't actually stop the overflow, but will help us debug it, or trap, which is rather unfriendly. I'd really like to be able to have a more friendly way to communicate to the compiler what sort of exception handling I want to do, instead of it just dropping an untracked UD2 or whatever to cause the trap. It would be nice if I could specify, use this chunk of assembly or something, so we could actually define the exception handling for these kinds of sanitizer failures. And then we could handle them gracefully, or decide if we want to saturate, or do whatever. Let's see, reading again, chat. Yeah, no, so Jacob's saying the 0 and 1, turning off the fake flexible array is fine. Oh man, I got to speed up. But yeah, I don't expect this to be a default option. I just want it to have an option so that we can turn on the kernel. Okay, built-in dynamic object size. We can basically add more knowledge to the runtime checking. Clang has this, GCC had it discussed. It would basically allow us to extend a bunch of the Fortify source stuff that we're already doing. I'm going to skip on. We've got signed overflow protection. There's an open bug that we've been chatting about, but basically we have an incompatibility between the sanitizer and what the kernel uses, which is no strict overflow. And we can't turn off the sanitizer using option attribute or optimize attributes because they cancel all of the optimizer attributes. So we haven't been able to use those. So we need some way to mix the signed overflow protection.
Also, there is explicit reliance on this behavior of no strict overflow.
Yeah, of course.
I mean, yeah.
Yeah, and those are the pieces that we want to be able to control, because we do use it in the kernel. So I can't use one or the other. I have to use both, but I can't use both right now the way the compilers are built. And unsigned, same thing. GCC doesn't have an unsigned overflow detector because it's not considered undefined behavior, which is fine. But
the reason for that is in C, unsigned overflow doesn't exist.
Right.
Unsigned types have a modulo.
Yeah.
You have to define semantics for it.
Right. So this is less about like getting rid of undefined behavior, which is a red herring. The issue is unexpected behavior. So we don't want, we want to be able to know when we're expecting to wrap around. And right now we have nothing that'll catch wrap around.
So you are saying that people do not expect C programs to follow the C standard?
Hmm?
You're saying unexpected behavior, but it's defined behavior.
Oh yes, I know, but
yeah,
it leads to bad situations.
Yeah, there is a lot of defined behavior that is a bug.
There's undefined behavior, which is a class of problem that a lot of things come from, but there's also a class of problems that is just C, the language, and like the situation of math and us not checking for overflow. And unsigned, in some situations we want to depend on the wrapping feature, and in many cases we do not. Wrapping is an unexpected situation that, while is legal, we don't want the kernel to do it.
You shouldn't use the unsigned type then. Oh really?
Yes, but pointers are unsigned. Most of that, it comes from pointer math. I'm going to speed up again because I don't have a lot of time. LTO, this exists. There's work to get this for GCC in the kernel, and I know Andy continues to work on it. I've seen him sort of chipping away at it, but I haven't seen a recent public attempt at it. But it looks like there is a lot of shared infrastructure with the Clang LTO in the kernel, so this is good. I just would be curious to see if there are other people working on this. CFI, I'm gonna just skip on past. We have some in Clang. It would be nice to have full-blown forward edge CFI in GCC. Right now, we mostly just got hardware support. Let's see, backward edge. We lost a software shadow stack on x86. We're mostly just waiting for CET, but CET, even in user space, is still not landed. So I beg anyone who cares about CFI pieces to go test the series that's been proposed for the kernel and get Linux caught up. I mean, we're shipping hardware with CET and the kernel just doesn't support it, which I find disappointing. And this is the totally bonkers thing that would help me with doing large rewrites in the kernel. Right now, we have a lot of instance equals kmalloc with some size or whatever else, and then rewriting all these so that we could take instance as an argument and use it is challenging in the kernel. But if we can refer to an L value, or at least get the L value type on the right side in the macro, we would be able to do some interesting stuff with type segregated allocations and a bunch of other stuff. I can get into this later if people have questions, but
why can't we just make a macro that does it now and call your macro instead of kmalloc? Instead of just
because I don't want to replace 20,000 kmalloc instances.
Like, why not? It's been done before.
Sucks. It has been done
before. A script can do it.
Yeah, I mean, we literally have Clang Tidy is meant to rewrite your code, right? Like if you can automate a check, you can run Clang Tidy on a code base and have it mass rewrite stuff for you.
I agree. I can have Coccinelle in an instance.
Coccinelle.
Coccinelle is part of
I know how to do tree-wide changes. The problem is that everyone gets angry about tree-wide changes, and I can't get them to
just
land.
think of your commit count and how important you'll be when people go look at your Git logs.
Yeah, that's not important to me. I want to get it done with as little friction as possible. So if we can do L value and introspection easier, then I don't have to do that. But sure, we could switch it around to do this instead. It's just a massive rework that we've had a lot of pushback. Like between all the work Gustavo does with refactoring, we've had things in the kernel that have taken 4 releases to do just because maintainers don't like having a mechanical change happen external to their tree. But we could have done in a single tree-wide hit at once. People get pretty upset about it.
Yeah, but once you get through it, it's there and it's done.
I agree. And as Nick is pointing out in the chat, there are going to be people who object to the syntax at all. The fact that it appears to have a side effect as opposed to an assignment. But anyway, this is just a fun idea that maybe we could do. But it's further down on my list. Struct layout randomization, still bonkers. There's a kernel plugin for this. It'd be interesting to have it in GCC natively. Clang has a proposed but stalled version of this as well. People use it, so I keep bringing it up. There's Spectre v1 mitigation. It's really expensive in Clang. It'd be interesting to have a more targeted version of this in Clang and something for GCC. Struct layout randomization works for dynamically loaded kernel modules, yes, because there is a single seed that is used for doing the randomization across all build objects. So
yes, yesterday there was this GCCF analyzer talk, and they were looking at trust boundaries, and that's exactly what you need for Spectre as well.
Exactly. That was what I was trying to talk about in the last bullet here, is like we need to have some sense of reachability, and that having taint markings would be really nice for that, because you could actually perform this kind of work against those taint marks. Okay, and now this is what's next. This is a king slide. I don't know how to give up.
Yeah, I think it's okay just to put there. I think it's not too much from me. Yeah, you can just yeah. I think for me, the major purpose for this talk is just to try to get some idea and suggestion on what's next important task for the GCC on the security feature. Yeah, to improve. Yeah, so that's because currently I already finished these two features. So I'm considering what's the next major task to improve the GCC security. Yeah. So, but right now, I think I might work on the known issue first for this already implemented feature. Yeah, as Case mentioned, there are several open issues for the core use register wiping. There are one RFE, I believe that's for x86 to request always use XOR for the zeroing. Yeah, right now I believe it's use some move. Use some move instruction. Yeah, so it's might not very optimal. So I think I will work on that one, and then there's another compilation time error for ARM. Yeah, so that's must be fixed next. Yeah, and there are also several other open issues for the automatically variable initialization. That's a very new patch just committed into GCC 12, 2 weeks ago. So there are some open issues there hasn't been fixed yet. So the first open issue is one missing warning, for the address taken variable. So that issue we already know before I commit this patch. We plan to fix this issue after the initial commit. And there are also some bugs opened after the initial commit 2 weeks ago. Right now, I believe there are 4 open bugs. I believe there are several open bugs already, part of them already fixed by Richard Burney, and there are still 4 open bugs right now. So I will work on those open bugs. So next page. Thank you. So after fix those open issues with this new two new features, I'm considering what's the next one for GCC. So as Case just mentioned in previous slides, from my understanding, maybe there are several issues might be important. The first one is adjust the signed integer overflow detector to work with if wrapper. So that's one maybe it's not very hard to do. Maybe just adjust add a attribute in the GCC, and then these two can work together for Linux for the kernel's use, right? Case. If we add a function level, function level attribute, Okay, so that one, and then next one is another task is provide an option to turn off the GCC heuristic or trailing array, flex array. Then the bound checking can work as expected. So I believe Jacob in the chat area mentioned it's durable because we need an option, but it's not on by default. So the default behavior still treat all the trailing array as flex array, so it will not break the existing application. But at the same time, kernel can have this functionality available for more security purpose. So that's the next one. And after that, maybe the unsigned overflow detection. So that's might be a quite a lot bigger project compared to the previous two. So yeah. So what else? What else? Any suggestions?
Just pick the less controversial one.
I think these will keep folks busy. But yeah, anyone else have thoughts or ideas or things they would like, please speak up. Oh, Randy brings up a good one I've run into too, is having like warning errors, the compile time warning errors print out values from that instance. I've run into that with at least the like compile time warning and compile time error. I don't have a way to include, usually it's some state that I got into. I have no way to express the state other than you hit this check, not what were the values of this check.
Mm. Okay, yeah.
All right. Well, if anything else comes up, we can do stuff offline. That's it. Here's the slide link again and how to reach us. Thank you.
Okay, thank you.
Case, another question.
Yeah.
For some of these things that you mentioned, do you have bugs filed for a bunch of these? They're just GitHub issues? Or?
I think I should have bugs filed for everything I mentioned. I tried to go back through here and get bugs filed. They should be linked. If I don't have something.
Yeah. The one with the frowny faces in the comments, that one was the one I was curious about.
Frowny faces, which don't I have a bunch of frowny faces everywhere?
Every slide. This one.
Yes,
Yeah,
this
no,
one,
no.
this one. Yep, coming back.
Here you go. Yeah.
Yeah, the with caveats, I think, and the trailing arrays have unknown size, I think are both existing bugs.
Yeah, yeah.
Yeah, I think the thing that's most interesting on our side is, given the resources we have, how do we prioritize shipping? And there's probably a bunch of things broken, and so it's also useful for us to have kind of some signal of like what's the value compared to how much work it is to implement, kind of thing.
Right, and I have trouble prioritizing that because I don't know how much work is necessary on some of these things. I don't know if there's a single place in the compiler that says, is this a fake flexible array, and you just add one check there, or is it scattered throughout? Because the latter sounds like a lot harder to fix. Bounds checking stuff would be nice to have it sort of all standardized and working, just because there are so many little corner case bugs that I keep tripping over. It's really hard to have a common working framework that we can follow a specific set of rules within the kernel and get the right behavior.
Hi. Could you please file a GCC bug for the zero length array?
I think it is.
Flexible. Oh, there is one. Okay.
I think so, yeah. Let's see. Like the with caveats one should be, I think, the link to that. But I could drop it in chat too. Anyway, cool. Please email us or something if you want to chat more. But thank you.
Cool. So we want to thank all of our presenters today. Everyone that put together a great talk, folks that stopped by and had questions and feedback for everyone. Really, the goal of Plumbers is to try to get like minds together in a room, even if it's virtually. Never enough time to sort out everything in person, but definitely a good start, and gives us topics to follow up on for sure, kind of thing. So thanks again to all of our presenters, folks asking questions, my co-MC chair, Jose, and of course, there's tons of work that goes on in the background, planning for Plumbers and infrastructure, and so much happens behind the scenes that folks are kind of none the wiser of when things go smoothly, kind of thing. So big thank you to all those folks, and of course the event sponsors as well. It does take quite a bit of funding to run all the infrastructure and everything. So thanks again, everyone. If you have questions, we do have the mailing list for Linux toolchains is something to check out. Kind of trying to keep topics that are interesting maybe to some compiler vendors and kernel developers as well. And there's a closing keynote in about 12 minutes if folks are interested. Is there anything else that we're missing here, Jose, or you think we're all set?
I think we can wrap it up.
Great. All right. Thanks again for your time, everyone. And
thank
you.
I don't know if you guys are sharing notes or taking notes or not.
Yep.
I have been
Yep,
in the
I got
chat. Please save them. There's the double little arrows up on top.
Yeah.
Yep, I got a copy.
Yes. I will be coming back to pester you guys for a write-up of everything that's happened throughout the MC, and I'm on the hook for my own MC too.
Is it possible to export the chat as well, or just the notes?
Yes, I will go through. It takes a bit of work. It's not trivial to do that. I will go in and do that, and I will send you a copy.
Cool. Elena says she has them as well.
Okay, if Elena has it, then have her send them to you. Save me the work.
Cool. All right, I'm just going to blast out the notes to the mailing list right now, kind of thing, so we have them at least, in case my machine goes down or something. Cool. Thanks again, everyone. See you.
Ciao, ciao.
Again, thanks very much to the sponsors of this year's Linux Plumbers Conference 2021. Facebook as a diamond sponsor, greatly appreciate all the incredible support that Facebook has given this year. Platinum sponsor, IBM. Gold sponsorship by ARM and Microsoft. Great support as silver sponsors AWS, Amazon, Netflix, and Red Hat. Thanks to Collabora for the speaker's gift sponsorship, and to VMware for the t-shirt sponsorship. Thanks to Linux Foundation for providing conference services to this, and to the great team of Planning Committee for the Linux Plumbers Conference 2021, chaired by David Woodhouse, Elena Zanoni, Kate Stewart, James Bottomley, Christian Browner, Jonathan Corbett, Guy Lunardi, and Steve Rosdet. Thanks very much for all of your help, and See you at the wrap up at the end of the conference.
Thank you.